Hey, what's up, guys? I'm gonna be on here in a second. Just trying to get something together. Alright, what's up, people? I'm KG.codes, Kelvin. I'm back on here doing another coding challenge. I've done these the last few weeks. This week I'm gonna do another medium problem. What I do with this is just go through a problem on LeetCode.com, try to come up with the solution, explain my thought process, ask questions. You know, people give me hints if they jump on, and I just go from there. So I think I'm gonna give it a couple seconds, let people join if anybody's gonna join, and then I just hop into doing this problem. So this problem is called Jump Game, number 55 from LeetCode.com. It's a medium problem. I definitely would say it does fit in the range of a medium problem, just because it has some gotchas to it. Like, it's not just it's not one of those mediums disguised as an easy. Like, it's definitely got some things that could trip you up in the interview if you either haven't done this problem before or haven't done the concepts behind this problem. It can be a little bit confusing. So I'm gonna give it a few more minutes, let some people join, and then I'll definitely go ahead and get this going. But yeah, this is LeetCode.com that I'm using. I'm gonna be coding in JavaScript, and I'm gonna try to work through this problem. I'm gonna try to explain myself like I would in a normal interview. I'm gonna explain the time complexity. I'm gonna try to, and I'm gonna explain the code, explain my thought process, explain the solution. Try to go through it a little bit slower than I would probably go through a real interview, because I'm gonna probably answer questions and try to explain myself a little bit more deeply to people. But I'm definitely gonna try to act like I'm in a normal interview. So anyway, without further ado, I'm gonna go ahead and jump into this problem. So LeetCode.com, like I said, the problem's called Jump Game, medium level problem. So there's easy, medium, and hard level problems on LeetCode.com. And this problem goes as such: you are given an integer array nums. You are initially positioned at the array's first index, and each element in the array represents your maximum jump length at that position. So what they want you to do is return true if you can reach the last index, or return false otherwise. And they have an example down here. Nums is your input, numbers, an array of numbers 2, 3, 1, 1, 4. The output is true, and the explanation is because you're gonna start here like they said above. You start at the first index, and you're gonna jump 1 from index 0 to 1. So when you're here, whatever number is here is how many times you can optionally jump. So you can choose so for this being 2, you can choose to jump 1 time or 2 times. For this one being 3, you can choose to jump 1, 2, or 3 times. And then for this one being 1, you can jump 1 time. So I hope that makes sense. So if you start here, you can choose to either jump 1 or 2 times because the number is 2. So in this explanation, it decided to jump 1 step from index 1, from index 0 to 1. So it made 1 jump from here to here. And then it chose to jump 3 times chose the maximum jump 3 steps to the last index. So it decided to do 1, 2, 3 to get to the last index. And it basically says return true if you can reach the last index, or false otherwise. And in this case, you could reach the last index. Example 2, you got nums 2, 3, 1, 0, 4. And the answer is false because you will always arrive at 3 no matter what. So it's basically, if you jump 1, 2, or 3 from here, you jump 1, you get to 2, and then you can only jump 2 here, so you can only get to 0. And then you can't even jump anymore right here, so you're stuck. And then even if you start here and jump to 2, then you can only jump 2 from here, you still get to 0. And then here, if you jump 1 or 2 you're still stuck. And if you get here, you can only jump 1. So you always get stuck at 0 no matter what. You never can get to 4. So the answer is false. And so it's kind of like a little game. It's like a game of like whether or not you have enough numbers and jumps to get to the end of the list. So you can think of it like jumping lily pads or something like that. And if you get to a lily pad where you can't, jump because there's nothing to jump to, then you're just kind of stuck. Or if you run out of energy to jump, I guess when you get to that lily pad, however you want to think about it. So one important thing that comes up in interview is constraints. You either have to ask your interviewer for the constraints or clarify the constraints with them. Sometimes they'll give them to you, sometimes they won't. In this case, LeetCode.com gives you the constraints. So it's basically saying nums.length, meaning the length of this array, how many numbers are in it, is always greater than 1. So we'll always have at least one thing in this array, and it's always greater than or equal to 1. So we'll always have one thing in there, and then it's less than or equal to 10 to the 4th power, which is a lot. But and I mean it's not enough to overflow the numbers, the integer data type in JavaScript, the language that I'm using. So the important thing you want when you see something like this is to just ask the interviewer, like, what is the max size of the length of the string that I have, and can my programming language handle that length of array? And then in this case, it's saying the actual numbers at I, which that means the individual numbers at each iteration in this array. How high can they be and how low can they be? Well, they're basically saying it can never be negative. It can be 0 up to 10 to the 5th power. And that's the thing you want to clarify with the interview, is that these numbers can't go beyond the range of an integer. Since this is an integer array, that these numbers can't possibly go beyond the range of an integer in the programming language that you're using. And in this case, we're fine because it's just 10 to the 4th power, 10 to the 5th power. That's not beyond the range of what the types of things we're looking at. So I'm trying to see on my phone here if I can see the comments. I can't see them. Like, this is weird. The phone thing doesn't show you the comments. It just shows you. So that was useless. So that didn't work out. So I'm gonna move that out the way. But I can still see the comments on my screen. And yeah, somebody asked, why are constraints important? I hope I answered that. Like, the constraints, if this was like, let's say this was 100 to the 4th power, that means, or just say this one was 100 to the 4th power, and I had like some like quadrillion number in here, then my programming language might not be able, if the number is, programming languages typically have limits for like upper and lower bounds for what an integer number can be, like how big it can be. It can overflow that data type and it'll cause an error in the programming language. And so what you want to make, like what some interviewers will do, is if they don't give you this constraint to tell you like, hey, it won't overflow your programming language, or it won't be a so high number that it'll like destroy your algorithm. If they don't tell you that, then you actually need to handle that case. Like, you need to code in your case to say, hey, if the number is greater than this, then you need to like error out of the problem, or you ask the interviewer what to do. Like, what do I do in the case that the number is too large for the integer data type? And in some cases, I've never seen a situation where they do that personally, but I mean, I don't know. I've always heard it was a thing. So this is something you want to clarify in an interview. So that's a good question. Why are you getting stuck? Were you asking about this example? Basically, this jump game, you start here, and basically whatever number that you're on is how many jumps you can make maximum. So here, this is 3. I can choose to make 1, 2, or 3 jumps from where I'm at. So let's say I choose 3. I jump 1 time, 2 times, 3 times, and then now I'm on this slot and I only have 0. 0 means I can't make any jumps, so I'm just stuck. I can't get to the end, and this problem wants me to say, can you jump to the end? And even if I start here and I decide to, instead of jumping 3 times, I jump 1, I get here, then I say, okay, well, let me try to jump 2. 1, 2, I still get to 0. And let's say I started here and I decided to jump to 1 because it's 3, I can get to 1. And then I got here and I jump 1, I still get 0. So I never can get to 4. It's like not possible with this game that we're playing here. And so I return false in that case. But this one, I could be at 2. I can go 1, 2, get to 1. I can jump 1 here to 1. I can jump 1 here to here, and I get here. Or I could decide to jump 1 from 2, or 1 from here to 3, and decide to use this whole 3 to jump 1, 2, 3. So it's a little bit confusing, but this is something you want to like clarify with the interview. If you're confused about the problem, you definitely want to clarify that with the interview. Like, how does this problem work? Like, if you can't understand the examples, that's something to stick with the interviewer till you understand it. Even if you have to tank the interview, because you're not going to be able to do anything if you don't understand what the problem's even asking. So you got to like prioritize understanding this. So I'm going to move on from it. I hope most people understand. If not, just keep asking each other questions, ask me questions, whatever, and I'll definitely try to answer. I'm not going to use Python. Somebody just asked that. I'm going to use JavaScript later on. But what I'm going to do right now in the interview, what you want to do, you don't want to just jump straight to code. It's best practice. I'm not going to tell you what to do, but this is my advice. This is the general best practice in the industry for these type of problems. Is what you want to do is you want to explain your thought process for you. You want to clarify the constraints. You want to clarify that you understand the problem. Ask any clarifying questions about the problem. If I didn't understand this, I would ask them like, hey, what does this mean? All that kind of stuff. Because they might not even give you examples. You might have to ask them for an example. So that's all types of things as you do these problems. You'll start to see what's missing and what you need to ask about. But anyway, what I would do is start to explain my thought process. And what I like to do is try to solve the problem in my head. Like, how would I just normally solve this mentally or logically, and then try to take that and convert that to code using data structures and algorithms that I'm familiar with, and able to be able to implement my plan or my strategy or whatever. So in this case, when I'm looking at this, basically it's saying that you need to get to the end with the number of jumps that you have. You start here, and then you need to try to get to the end. And the thing that I'm seeing is that, at least at first thought, is that at each step I have a combination of things I can do. I can, like, if the number's 2 here, I can jump up to 2 times. So not just 2, but up to 2. So I have here I could jump 1 time or 2 times, and then so I could either get here or I could get here. This is already diverting my paths that I can go. So if, let's say I jump 1 time, now I can jump 1 to 3 times. I could jump here, I could jump here, or I can jump here. And so I feel like I would, at first thought, I would try these different things. Like, it's easy in my mind, like if I jump here, get to 3, and I know I have 3, then I'll be done. But when you're writing an algorithm, you have to pretend this could be anything. This could be any list of numbers. And in that case, in my mind, I would need to try out every single jump combination until I find one that gets me to the end. Once I find one that gets me to the end, then I would just say true, like I got out. So I would try one, like here I would try to go down the path of stepping 1s and stepping 2. Here I would go down the path of stepping 1, 2, and 3. Here you only have 1, so I'll just go down the path of stepping 1, go down the path of stepping 1, and then here I'll be at the end, so I wouldn't, do anything here. I would just say, hey, I got to the end, so everything's great. So yeah, that's what I would do. I would just try all the different combinations and paths until I found one of the combinations that got me to the end. That's at least my first initial thought about this problem. And the thing I've learned through doing these problems is that whenever you have a problem that is like number of ways, or you're trying different combinations, then you're sort of building a tree. Like I said, like every time I try a different path, it's like branching to more paths. And if you know about like trees in programming languages, that sort of creates like an upside down tree of like branching paths. Like I start with 2, and then that branches into 2 options, and then that 2 branches into 3 more options, then that Then, on the other side, it's starting to branch into other options. And in that case, then I'm starting to think about a backtracking or a depth first search algorithm. And that's something you would have to study. And that's why a lot of times when I hop on here, I talk about using like tools like Algo Monster, Algo Expert, YouTube videos, tutorial sites, whatever you want to use to learn, but learning the fundamentals of data structures and algorithms so that some of those things come to mind. You start to learn pattern recognition, you start to see problems, and you start to be able to assign the data structures and algorithms that you've learned to those problems based off of like the wording and based off of how the problem is. And so the first thing I actually do want to try here is a algorithm that basically will, at every step that I go through, try all the different combinations until I find a combination that gets me to the end here. And if I get stuck, like where I can't go anymore, or I never find anything, then I just return false, like in this example number 2. So some of y'all, like I know some of y'all on here have or maybe thinking about some different solutions. I'm gonna go through the solution that I have. Like if I'm in a real interview, it's gonna be whatever comes to mind first. And if you can't think of nothing else, you're at a time limit. And that's the unfortunate part of these problems. You're sitting in a time limit, so you do have to kind of move. Is this the most optimal solution? We'll see. We'll see if this is the most optimal solution. A lot of times I do know from programming this solution of doing the backtracking and checking all these different combinations, that tree can get out of control really quick. You can get a lot of different branches on that tree that can make your algorithm inefficient. But right now that's what the problem is showing me. So that's what I'm gonna do. So yeah, I'm not gonna keep talking about it. I'm actually gonna jump into the code now. So I just moved that over here. And somebody said, what did the constraints say, George? Constraints are down here. So 10 to the 4th power, 10 to the 4th power. The length of the array can't be more than 10 to the 4th power. And then it's going to be at least 1. And then the similar thing for the actual numbers inside of the array, like these numbers. They can max, like each one can at a max be 10 to the 5th power, and they can be 0. Like we see here, it can be 0. So I'm pretty confident, like with these maximums here, these constraints at the higher end, that I'm not gonna like overflow anything, or I'm safe to kind of just program with these numbers and not have to check for like edge cases when these are too large, because I think these numbers 10 to the 4th power is fine in JavaScript. I don't even know what number that is, but I just know from memoization that it's a JavaScript can handle that size number in an integer data type. So yeah, it's a good question. You got to ask about the constraints in the interview for sure. But anyway, we're gonna jump over here. LeetCode, what it does is scaffold out the problem for you. So the function they've scaffolded out is called canJump. This is nums, like we saw over here, nums. So that's the thing you have to think about if you're not used to doing these problems. Nums can be anything. These are just examples 1 and 2. These are just examples, but nums can be anything within these constraints. So that's why these constraints are important, because it's not just going to be these. Anything can be run through here. It could be 10 of these. It can be 100 of these. It can be up to 10 to the 4th power of these numbers. So my algorithm needs to be able to handle that much. And not like time out and not have issues. So anyway, this is nums coming in right here. So it's just whatever nums is, my algorithm needs to be able to handle it. I'm actually going to change this to const. If you write JavaScript, you may understand why that using const is better than using var here for hoisting and just best practice. So anyway, I'm gonna just change that to const before somebody come on here and say something. But yeah, and somebody said I wouldn't say that's the best solution, but that would be the easiest to code fast and kind of brute force. Totally agree with you. Like if I'm in an interview, and I gotta get something down. Sometimes you just don't have the best solution in you, but you have a solution. As long as you talk through it with the interviewer and tell them what you're doing, they may try to stop you. They may try to let you go ahead and go. Just take their feedback. Don't ignore their feedback, and just do what you can and explain your thought process. And sometimes in those cases, that's the best you can do. Because sometimes you just don't know what the best solution is at the time. So I'm gonna go with the solution that I thought of first, and that is basically a recursive algorithm, depth first search algorithm, backtracking algorithm. I guess the best classification for what I'm about to do is a backtracking algorithm that is going to use recursion to help me find all the different paths that I can go down until I find a path that gets me to the last one. If I don't, then I'll just return false. If I do, then I'll return true. And hopefully this will make sense as I start trying to write this. And so I do know whenever you're writing like a backtracking algorithm that you're going to have some sort of recursion going on. So in order to do recursion, you need to have some sort of other function you create. So I'm going to go ahead and create this second jump function. Can jump is like give me the answer whether I can jump or not. The jump function is actually going to be my recursive function that I use. And the thing about when you're doing like depth first search and backtracking algorithm, that your recursive function always needs to carry some state throughout it. And I know I have num, so I'm going to go ahead and put nums in here that I'm going to carry its state. And I think I'm going to, what else do I need to know when I'm recursively calling this? So like I know here that I kind of need to know what index I'm at every time I make this recursive call. And I know this is a medium problem, y'all. So I know if you're new to this might be a little bit beyond, like I've done some easies on here before. So this one might be a little bit beyond. For some of y'all, it's going to be easy. For some of y'all, it's going to be hard. But I know that for some people, if you've never done recursion, if you've never done backtracking algorithms, if you've never done depth first search, if you've never done anything similar to this might be a little bit difficult how I'm thinking through it, because there's certain things I already just kind of know. But I know I need to keep track of my current index where I'm at. And so now I need to make use of this function. I'm going to go ahead and make use of it before I even fill it in. But I know here I need to return jump. And then I need to think about what do I need to pass? What is this? You always want to think about state when you're writing like backtracking or depth first search algorithm. So I know I need to pass in nums. I just pass that in as is. It always just get passed in as is. It always maintain the same state because that's my input. But here, my current index is 0. And why is it 0? Because that's what the problem says. You're initially positioned at the array's first index, which is 0. So I'm going to pass in 0 as my first state. Like that's the first state of this algorithm is what I'm going into. So I'm going to come into here with nums. I'm just going to pass nums through, pass by reference. And then I'm going to pass in current index. And this is the object. So in JavaScript, objects automatically get passed by reference. It's an array. So it gets passed by reference. This 0, since it's a primitive in JavaScript, it gets passed by value. And all that means, passed by reference, just means that if this got mutated, like as far as changed or whatever, the change would actually like bubble up to the, top of the recursion stack. But passed by value, it just passes it in, and it's not really keeping state of that in the parent functions that called it, if that makes sense. So yeah, so anyway, we're gonna start. Let me make sure I'm watching questions and stuff like that. Why don't you use Python? So I actually program mostly JavaScript right now in my day job. So I'm mostly gonna use JavaScript. The last time I did an interview run, I used JavaScript. Python is a great language to do for these, but JavaScript is really good too because it's also dynamically typed. It's not as syntactically like simple as Python. Like it's a little bit more verbose, but it's not nearly as verbose as like Java languages like Java, C#, C++, stuff like that. So I think JavaScript's a great language to do coding interviews in. But you know, a lot of people just like swear by Python. I get it. It's great too. But yeah, I use JavaScript. So, and you're gonna, if you know Python, you're gonna be able to understand the JavaScript code I write. You're gonna be able to understand it really easy. But I understand the question why you're asking that. But anyway, yeah. So yeah, let's do this. So we're in here. The first time we call this, we're gonna call it with nums, and the current index is gonna be 0. And the thing is, with these recursive functions, you want to check your state. So the first thing I said is that I want to just make sure I'm trying to get to the end, right? And so the first thing I'm actually going to check is whether I'm at the end. And if I'm at the end, then I can just return true. And so what I want to check is if nums at the current index, so that just pulls out the whatever current index I'm on, it just pulls out the number at that index. That's how you pull it out in JavaScript. If that number, oh no, that's not what I want to check. I actually want to check, see, I'm already messing up. I actually want to check if I'm at the end of the nums array. So if current index is equal to nums minus 1. What nums minus 1 gives you is the end. That's the last index. Because indexes start at 0. And when you're normally counting as a human, it starts at 1. So you got to subtract 1 to account for indexes starting at 0. So what this actually does is just give me the last index. If my current index is the last index, then that means I've recursed enough to get to here. If I've gotten to here, I'm good. Like that's a true. And so that's kind of something I want to check immediately when I get in here. And I just want to go ahead and return true in that case. And so, god dang. Okay. So yeah, if I get to true here, I'm good. But I may not have true here. So if I don't return true here, then I got to keep going. And now what I want to do is, like I said, like I was thinking through mentally, is that at each iteration, I want to go down the path of, like, for 2, I want to try jumping 1 time and jumping 2 times. For 3, I want to try jumping 1 time, I want to try jumping 2 times, and I want to try jumping 3 times. So I actually need to loop through the times that I need to try and jump that many times. And so what I need to actually do is like create a loop, and this is just how you just have to memorize how to create a loop. And it's however max number of jumps I need to jump. So is it less than or equal to? Yeah, I think less than or equal to. And then I'm actually gonna go backwards. I'm gonna jump the farthest first and then go backwards from there, because I think the algorithm would be better if I try to jump the furthest, as long as it's not the end. So what I'm gonna do is, I'm gonna start at the max amount of jumps I can make, and then as long as it's now it's gotta be greater than or equal to 1. Because once I get to 1, I don't want to jump 0. I can't jump 0. So as long as I is greater than or equal to 1, and I keep going, and then I minus to decrement. So basically this loop, starting at the number of jumps, and let me make sure I put the number of jumps here. Max jumps. Max jumps is like whatever number is in each slot, right? So we know that that's the maximum amount of jumps I can make. And so I'm going to put, now that actually is nums at current index. That gives you the max jumps. And basically what I'm doing, I'm going to start at the max number of jumps, and then I'm going to go backwards until I get to 1. And then once I get to 1, then, that's the smallest jump I can make. And so I'm going to do that. And the other thing about max jumps is, if I'm thinking about this case. So like, let's say I'm like, let's say I'm here. I wouldn't be here because this is the end, but let's say this was like 3 and it goes beyond the bounds of my array. I actually don't want to jump beyond the bounds. So I actually like, if this is too long, then I actually don't want to, I actually just want to jump 1 if this is too long. And I don't know if the problem doesn't say in the constraints if that's possible. It actually doesn't show that that's possible here. But I'm wondering if like there's a case where this can jump past the bounds of the array, which I don't want to do. So actually my max jump would be either in JavaScript you can find the minimum between 2 things. It would either be the minimum of this, like whatever the current number is, or, and let's see how to do this. I think the number, yeah, the nums minus 1. So this would give me the end of the array, because I just don't want to go beyond that. So let me think of how to do this. So yeah, I got, so if max jumps and the end of my array is here, and I'm jumping 3. Oh yeah, so it would be the minimum of whichever one is the minimum of this minus current index, I think. Yeah, I think it's, yeah, so I think it's number length. I don't have to put these commas here. Num's length would give me the length of the array. So that would give me so here it would give me 5, but the index is starting at 0. So this index would actually be 4. So to account for that, I would subtract 1. And then I would also subtract the current index, which I didn't mean to do that, to give me the difference. And so what I'm doing is basically I'm saying give me the minimum of either the number that's currently in the slot I'm on, the current index, or the end of the whole thing minus the current index, whatever I got left. And if what I got left is less than the number, then just use what I got left, if that makes sense. Now this might be a little difficult to explain, but basically I'm basically saying if I'm here, let's say this instead of 1 this was 4 and I don't have 4 places left, I'm saying just jump 1. Just jump 1 time, then don't try to jump 4 when there ain't nothing left to jump. Because you can't jump more than the end of the string anyway, the end of the array anyway. So this is what this accounts for. So this basically gives me the maximum jumps, either jump as far as you can or just jump to the end of the string. Because if the number is farther than the end of the string, then just jump to the end of the string. Don't try to jump too far, if that makes sense. Because you can't jump farther than what you got in the array. So I hope that makes sense. Yeah, it's a little tough to explain, but anyway. So anyway, when I get in here, now I'm jumping the maximum amount of times, and then I'm kind of like jumping smaller times, and these are all my different paths. When I get in here, I actually need to do my recursive calling, and I'm gonna call this function again, jump. I'm gonna call it again inside of here. And I'm passing in nums again because I'm just going to keep passing that in as is. But then what is my current index that I need to pass in? So this is where I'm actually making a jump. So whatever my current index is, I'm actually going to add to it I, because I is my current jump. And this whole thing is either returning true or false. And so what I need to check here is if jump is true, then I need to return true here. And then I can return true out of this whole thing, out of this recursive function. If I get down here without ever returning true, like none of my things return true, then I'm actually going to just return false down here. But yeah, so here I'm just trying to see if any of these, and I might just be able to, I guess I could just, can I just return like, yeah, just do this. I guess I could just do that. I'm trying to think of the reason why I wouldn't do that. Yeah, because I'm just going to return. No, I can't do that because I need to see. Yeah, I need to check if any one of these is true and only return true if one of them is true. Because if none of them are, because I don't want to, if I return false on the first one, then I'm going to like, yeah, I can't do that. I just need to check. I need to use a return here to do an if statement, but not actually return until I find one that's true. And then I return. So yeah, I messed up there, but yeah. And then if I don't find any, then I just return false. Like if I don't find any that are true, any paths that are true. So what this starts off another a whole recursive path. And so what this algorithm is doing is basically like when I'm at 2, it's saying try 1 and try 2. And so this loop, let's say max jumps was 2. This loop is I is gonna be 2 and then I is gonna be 1. And it's gonna try to jump with both adding 1 and adding a jump of 2 to jump. And if either one of these returns true, then I'm gonna return true out because that means I got to the end of my thing. And the only way I can get there is this first case here, is when I actually get to the end of my array. If not, then I return false for that path. And it's just recursively will come all the way back up to here and give me the return of the whole can jump function. And that's just how recursion works. So yeah. Anyway, yeah, somebody said it's crazy I'm watching someone else code about while my machine learning code runs. Okay. That's what's up, man. But yeah, and then somebody said Claude Code solved this in 5 seconds. Yeah. I'm starting to hear that like companies are starting to change their interview practices from asking these kind of questions to like letting you use AI and do all this stuff. But at least as far as I know, the people I've seen that like friends and stuff that are interviewing right now, they're still asking these kind of questions. So yeah, the AI can solve it, but some companies still want you to be able to do this on your own. So that's kind of the problem. They want you to understand the fundamentals, even if you have AI doing it for you. They still want you to understand what the AI is doing. So yeah, that's kind of where we're at with that. But anyway, yeah, to understand recursion, you must begin by understanding recursion. Yeah, it's tough, man. But anyway, once you understand it though, you got it. It's just trying to get there. But anyway, I think I'm like done. Now that I'm looking at this, trying to think, yeah. And so if I got to this point in the interview, I would review each line. Like, yeah, here I'm calling jump, passing nums, passing 0. If current index is equal to nums length minus 1, that means I'm at the end of my array, then I return true. Max jumps, I want the minimum of either, let me see. Yeah, I either want the minimum of the current number that I'm on or the end of the array minus the current index. And so if this is higher, which most of the time it will be, then I want to just take the lower one. If not, if this is somehow if this one is somehow higher, I want to take this one. But if this one is somehow higher than the actual amount I have left, I actually want to take this one, that's what math min does. And then here I just loop through backwards. So I start with max jumps and then I don't, I stop at 1 and I just keep going backwards. And then I just do a jump to check if I get any trues. Any trues are coming back from here. If any trues come back, I return true recursively. If not, then I just return false recursively. And so yeah, this looks good to me. So if I got to that point, I would oh shoot, sorry about that. Make sure my mic's still working. Yeah, I would review my code. So in some interviews, they would have you maybe run this code manually, or they would have you run the code with a coding editor. Some interviewers don't allow you to use a coding editor at all. Some do allow you to use a coding editor. Oh yeah, I forgot to put this on the screen. Yeah, I'm tripping. So this is the actual problem that I'm working on right now for anybody that's joining at the top up here. I meant to put that on the screen before. But anyway, it's on there now. I know it's kind of small, but yeah, it's a lot to put up there. But anyway, yeah, interviewer might ask you to run this manually, or they may ask you to run it in a coding editor. Sometimes they don't. I've been in interviews where they don't even have nothing to run the code in. If they don't have anything to run the code in, you need to like run it like by like hand, like manually. You need to keep track of the variables. You need to try input and make sure it works as expected. I'm actually not going to do that. I usually do that every time I do this. I'm actually going to do that on the last iteration of this. I'm not going to do it right now because it takes a really long time, especially with recursive problems. And last week when I did this, I tried to do it with the recursive problem and it took forever. So I'm not actually going to do that, but I just want to make that be a point that, you know, some interviewers, like especially like when I did an interview from Amazon, they didn't let me run it. I think Airbnb, they didn't let me run it. They made me trace it by hand. So, but I'm gonna do it later. I'm just not gonna do it on this algorithm here. So most of the interviews I've been in, they actually do let you run it and debug it. And so what LeetCode allows you to do is you can just press run up here, which y'all can't see it, but press run. And so, okay, so here I got the wrong answer. The right answer for this one. So I'm always getting false. So I must have messed something up in my algorithm. So 2, 3, 1, 1, 4. And I'm getting false, but I should be getting true. So I must have messed up something in my algorithm. So I didn't check it quite well enough. If current index is equal to, is this right? Nums minus O. Oh yeah, I see where I messed up. Thank y'all. I appreciate it. Thank y'all right here. Appreciate that. All right, I'm gonna try it again. See, that's why you got help, man. I appreciate y'all. See, that's all it was, man. Somebody had it. Who was that? Michael Dubé. Somebody else said it too, I think. I don't know. Yeah. And yeah, if you're able to run this, you can actually do like hello worlds in here and like console line and kind of debug it. Some interviews will let you do that, but some like literally, it's been some interviews they had me write the code in Notepad in like a Word document. You didn't get no code help. You didn't get no autocomplete. You just had to know how to run the code yourself. Like you had to like what I would do is normally is like I would keep track of all the variables, like, you know, whatever the variables were, and then I would just like, you know, line by line just keep changing and updating the variables till I got to the end to verify that my solution worked. But here I see that at least for these two test cases, what LeetCode does is it takes the two test cases from over here, example 1, example 2, and it just so that's example 1, case 2 is example 2, and it just makes sure that your algorithm performs puts the expected output. So looks like my algorithm's working. And then what LeetCode also allows you to do is submit it against a lot of different inputs, like a super long input, short inputs, edge case inputs, you know, like 10, 11, 20, 100 test cases sometimes. And they also like measured against other people. And so, you know what I did skip though here? If I was in an interview, what I would actually do is need to talk about the time and space complexity. So time and space complexity of an algorithm is basically a way to analyze the performance of your algorithm as it pertains to time and space, and based on the size of your input. So how does your operations and time of your algorithm running scale, like number of operations and time that it runs, how does it scale in relation to your input? In our case, the input is the length of these, how many numbers I have, and like how long the array is. And space complexity is how do the data structures and runtime memory you're using in your algorithm scale in relation to the size of the input. So time complexity is how many operations, how long the algorithm takes to run, how many operations it has to do in relation to the scale, in relation to the size of your input. And space complexity is like how much memory you're having to use in runtime in order to process the input in relation to the input. So that's denoted by something called big O notation. And yeah, that's just something you have to kind of learn on your own. I'm gonna go through it at least to what I know about these algorithms. So I do know that what's happening here is that I'm doing this recursive function, and when I get in here, every time I hit a new level of this recursive function, I'm actually having to try even more recursive functions up to the size of the maximum jumps, which can be different every time. It's whatever this number is in each step. But I know that I'm gonna, at least in each jump, I'm gonna go like 5 levels deep in this case, and that's the size of this nums array. So let's define like n equals nums dot length, and that's usually in big O notation. N is usually kind of the size of it represents the size of your input, and in this case it's the length of the num string. And I know that I know the recursion is going to go in deep, because I'm going to have to keep calling recursive levels for each step that I get to. Like here, I'm going to create 3 more. Like here, I'm going to create 2 trees. Like I'm going to create 2 paths, 2 options. Here, I'm going to create 3 more. Here, I'm going to create 1 more. Here, I'm going to create 1 more. Here, I'm going to create 4 more. And that's like, as like these branch off, like it's creating more and more. It's not just like 2, 3, 1, 1, and 4. It's like 2 is creating 2 paths, and then each of those paths is creating more paths, and then each of those paths is creating more paths. So it's like, it's literally exponential paths. And so that's how I would actually define it in big O notation. And how you define exponential growth in big O notation is big O of 2 to the, where's the key? To the nth power, where n is the level of depth you're going through with your exponent, like the level of depth you're going through as far as your recursion or as far as your backtracking or whatever the case is. 2 is actually it's actually the number of how many like diversion paths you're creating on each level of depth that you're going into. So in my case, I don't even think it's actually 2. I think it's a whole nother number of like whatever these numbers are. And so here, if I was creating 2, right here, I'm creating max jumps number of paths each time. It can be whatever that number is. If I was just creating 2 different paths each time, like we see with binary trees, then this definitely would be 2 to the n power. But I think it's actually like, if we define like C as the, what can I call it? Like varying number of jumps, which is denoted by, it can be between 0 or 10 to the 5th power, then I actually think it would be big O of, it's still exponential, but it's big O of C to the n power. Or you can call C something, you can call it any variable, and it doesn't have to be C. But a lot of times, what I see it called, like in a lot of problems, like when you just go and study big O notation, it's usually, they usually just use the number 2. But I think technically it would be like its own variable, like separate variable from n. And then this is called exponential time complexity. So this is how many operations are being done. And the reason why it's that is because I'm basically measuring how many operations that have to be done based on the size of this input. Like how many times is jump having to be called, and that is growing. Like what in my algorithm is growing with the size of my input, and that's basically how many times the number of jump needs to be called. Now some of these lines are considered like constant operations, like these individual lines themselves are constant operations, but this loop here is important, and I think that's what helps define the C, is like how many times this have to run on each iteration. It's whatever these numbers are in here, and how many times jump needs to call to like how many different levels is basically C to the nth power. The number that I have, like the number of numbers I'm getting, times whatever the number is of like the number of paths that I'm going to have to diverge on that level. And that's how I get there. Now this is one of the hardest time complexities to explain, exponential. It is pretty hard to explain. But yeah, that is what it is. And so number of operations is what time complexity exponential. I spelled that wrong. And then you got to think about space complexity. Okay, space for so space is basically measured off what sort of data structures are you using in your algorithm that are growing relative to the size of your input. In this case, my input is an array, but I'm not creating any other data structures in it. I'm not creating like arrays, new arrays. I'm not creating any objects. I'm not creating any maps or hash maps or anything. But what I am creating is what's called a recursive stack. So every time I go down a new level and recall this jump, it's actually saving the recursive stack in memory, because as I go down a recursive stack and it starts to resolve, it has to unroll the stack, if that makes sense, because I'm going deep into this stack, but eventually I got to come all the way back up to here and return the answer. And so it creates these recursive stacks of state that it has to hold on to as the answers keep getting returned back up the chain. And so that actually happens n times based on whatever the number of my input is. And so in this case, it would be big O of n, which is also called linear complexity. And in this case, it's the space. It's representing the space complexity. So this one is either, you can say, I mean, you can also call it 2. I think an interviewer will probably accept 2 to the n power as well. Big O, like exponential. As long as you just said it was exponential, you'll probably be fine. But I think they'd accept this or this, I think. I don't know. Y'all just let me know what y'all think. Some of y'all that know. So anyway, yeah, I'm at this point now where somebody just said something. Tiger Couch Yellow, you said you don't need to calculate all the jumps, just need to make sure you can get past any zeros in the input. And I'm kind of with you there. I think whenever you get a solution, where you're got an exponential time complexity, a lot of times it's not going to be good enough for an interviewer. And I'm going to see, you know what I'm going to do right now? I'm going to see if it's good enough for LeetCode. I don't think it will be, because it's exponential. Usually LeetCode doesn't accept exponential time complexity answers. And I see how long it's running. So yeah, I got time limit exceeded. So 78 out of 175 test cases passed. These test cases down here passed. You know, these were fine when it's like the numbers are low. But when the numbers when I have a extremely, you know, a lot of numbers in here, like this many, I don't even know what this is. I mean, it's a lot. Obviously. Oh, I guess it's 10,000 or whatever, or 9. I don't know, something like that. It's a lot. So my algorithm actually fails. like LeetCode's time exceeded. So the algorithm actually probably would eventually work as long as your computer like had enough CPU to compute it, but it's not an efficient algorithm. As this number goes up, you start to have issues. And I mean, it's possible the computer might not even be able to do it. I mean, LeetCode couldn't do it, but I think they have a timer, and like if it just exceeds that timer, then they're like your algorithm isn't efficient enough. I'm gonna analyze the time complexity, what they think it is. Yeah, so they said big old 2n. So I guess you say it's big old 2n. I think it's c to the n power. But yeah, usually you can represent it with 2 to the n power and it'll be fine. So that's why I put either or. And then where's the I guess it doesn't have a space complexity since I didn't get it right. I can't measure the space complexity. But anyway, so yeah, this answer isn't really isn't optimal is what I'd say. And so what are some ways that I can optimize this? Can you make it logarithmic? Nah, I can't make it that good. That's really good, actually. Like, if you can get it logarithmic. I don't think I can make it that good, but I think I can make it a little bit better. And I think the issue of what is happening is that I'm actually... never mind. The issue of what is happening is that I'm actually being sort of wasteful here, because if you look back here, I'm repeating stuff over that I don't have to repeat, like answers. So like, how can I explain this? So like here, when I start here, I can jump 1 or 2 times, right? So I can jump to 3 or I can jump to 1. And so what's happening is, let's say when I jump 2 times, I get to 1, and then I jump one time, and then I jump another time, and I get a true here. Like I actually get true here. And so when I actually go to try the second step here, jump 1. Well, let me start over because I think I'm confusing myself. But anyway, like here I have 2 options, right? I'm gonna go down 2 paths of jumping 1 or 2. So when I jump 1, that gives me 3, and then 3 jumps here, and it gives me 4, and so that's the end of that path. And then, but I also have to try the other path of jumping 2 to 1, which gives me 1. And see, I already messed up, man. It's so freaking confusing to do this, man. All right, I'm gonna get it right this time. All right, so we got 1 and 2. This is 2, right? This is 2. I got 1 and 2 jumps. I'm gonna try jumping 1 first. This is 3. I got 1, 2, or 3 jumps. I'm gonna try jumping 1 first. I get 1. This is 1, so I can only jump 1. This is 1, so I can only jump 1. I get an answer of true. So that means I got an answer of true here. That means I got an answer of true here. Answer of true here. Like once I get true here, I know that this path will return true. And so because I know that path will return true, then when I try my second path here, like of trying 2, when I get here, I should already know this is true, because I already tried it in my other path. I already know that when I start here, there's a path to get to 4 because I tried it in my other path. I hope that makes sense. And so basically what I'm saying is, if I just stored the result of everything that I'm getting, if I see that same index again, I can actually just pull the result out of memory instead of running the rest of that code like over again, because I've already ran it before. So why do I keep running down the same paths I already went before? So that what this is called is memoization, where you actually store results that you've seen before, and you basically trade a little bit of space, or not a little bit, but you trade space for time. And so instead of keep running the same algorithms over again, I actually just store the result in runtime memory and use that to help me save on time complexity. Because what happened here is in my algorithm is that it was the time complexity that was exponential. It was just exponentially bad. Like for every length that I like, however long this algorithm gets, it's like 2 to the nth power of that, which is terrible. But the space was fine. Like space was linear, meaning that however long my number of nums was is how much space I use, because I'm just building a recursive stack. So what I could do is trade some of this time complexity by using more space. That's a common thing you do in coding problems to help save on time complexity. Trade time for space in order to reduce the time complexity. So if I just store the results that I had, that I found already, then when I go down different paths, just use the result that I already stored. Instead of just going down that, running those operations over again. I'm repeatedly running the same operations because I'm going down, the paths are converging and like copying each other and all that stuff, if that makes sense. So what I can do to solve this is what people usually do, is just create a variable called memo, and I'm just gonna create like a map, a simple map, which you can in JavaScript you can do new map, but it's actually easier just to do an object because objects perform the same as maps in JavaScript. So, and I'm actually gonna start passing that into my state. So I'm gonna open up a new variable here to pass this in. It's gonna keep my state. And so actually what I'm gonna do is actually here I'm gonna keep this. If I get to the end, I want to return true. But also in this case, I'm thinking, do I need to actually store the result here? I think I do. I think I need. So I think here I want to actually restore the result for current index. I may be wrong here, but so basically what I want to do in this memo, this is like a date. Think of it as a database or a way I can store information. At current index, whatever current index I'm on, since I know the result is true now here, I'm actually going to set this to true. And then here, I'm actually going to check, even if I don't get true here, if I'm not at the end, even if I'm not at the end, I still want to check this. Because I might not return out here. This may not be the case. I may not pass this. I may get here, and I actually want to check if I already have a result in the memo for that index. Because if I do, I don't need to try all these different things and go down these different paths no more, because I already know what the result for that current index is because I already saved it. And so here I actually would just return true. Or no, I actually think I would just return if I have, no, wait, hold on. I think I might need to do this different because I think I need to say, I think I actually need to say if, I might actually need to make this a map because I need to check if it's actually, I can't, because it's true or false, I'm storing. So I might, or I can just check if it's not undefined. This might work, but it might be better for me to use a map though. I just can't remember what the map function names are. Yeah, I'm gonna use a map because it'll make more sense. So this, I'm gonna do a little switch up here. Use a map. And I'm gonna say in a map, I think you use set current index. So it's just a little bit different syntax when I use an actual map. So I use the set function on it to set current index to true. And so here I'm actually gonna say, does it has an answer? Has return a boolean, and just asking, do I have something set at that index? If I do, then just return what I have. And I think that's just get current index. I hope. I might have the syntax messed up, but yeah. So the reason I did this is because I need that boolean to check here, and since what I'm storing is a boolean, it would mess up my logic right here, if that makes sense. So I need to I'm actually using a map data structure in order to do this more properly. And so here I'm just like returning my information. It's basically a database to store my results so I can return the information more properly. And so I also need to do the same thing here. Whenever I find out something is true, I need to go ahead and set my or whenever I find out whatever the result is, I need to go ahead and set my memory. And so down here I need to also set the memory if I get down here too. And I'd set it to false instead though. And so yeah, here I'm setting the memory to true. Here I'm setting the memory to false. Here I return the memory if I got it. And then here I also return it to true. This one I actually don't know if I actually need to do, but it probably don't hurt to do it. I don't think. It may just reset the same thing. But we'll see. So yeah, and I think this is right. Has and get. That's what I'm just not sure if it's like set, has, and get for a map. I can't remember because it's maps and sets. I can't remember yeah. But set doesn't return a Boolean value. Set doesn't return anything. It's just like setting the value in the map. Has is checking. Has doesn't get you the value out of the map. It just checks, do you have a value, true or false, in the map. And then get actually goes and get that value. See, I can't just check get because get can be true or false. I actually want to know which one it is. I can't use it to check if I have something in there, if that makes sense. So that's why I'm using this map. So anyway, yeah, so this to me is a little more performant because I'm actually going to start stopping here if I already saved that for the current index. I already know what the result is for the rest of that recursion chain. So I don't need to go through it again because I can just store it and just use it. And so this will reduce the number. It will actually make me backtrack a lot more often because it'll immediately stop my recursive tracks when I've already went down them. So I'll only go down these paths one time. And so what that does is actually help reduce the time complexity here to what's called n squared. And I'm going to say, that's also known as n times n, which is n squared. And so because what's happened is I'm not actually trying as many. I'm not getting down here as often anymore. I'm only getting down here when I have a new path that I haven't seen before, and I immediately stop after I've saved some results. And so it actually, I'm trying, in operations times another in operations in that case, because I'm not ever repeating any paths that I went down before ever again, if that makes sense. It's kind of hard to explain, but it basically lowers memoization, helps you lower a exponential, and I'm sorry, this is actually called quadratic time complexity instead. It actually helps you reduce an exponential time complexity down to a quadratic. Now the space complexity, I still have the same recursion going on, so it's always going to be big O of n. And now I'm trying to figure out, now I'm using a map, so I think it's not multiplying. I think it's still n plus n, which will be 2n, which I believe just still reduces down to big O of n, I think. Because because 2 times n is just, in big O notation, those coefficients reduce down to nothing, and you just still get the same thing. Now, whenever you're like time multiplying something, or like using a exponential or something, then it doesn't reduce. But whenever there's like, some coefficient, then constants usually in big O notation will reduce down to nothing. I think that's the case. Because I think I'm using a map now, but it's only going to grow to the size of current index. Like, I'm never going to store more than each of my indexes. So I think it's always just going to be the same 2 times n, I think, but I could be wrong there. So anyway, this memoization helps me memorize results and kind of reduce some of the paths that I'm going down. So I'm gonna try to run this. I'm not gonna trace through the code again. I already talked. This is gonna take too long to do because I'm gonna have to keep a track of the map and all that stuff. In an interview, I probably would try to do it, but I'm not gonna try to do it on here. It's gonna be so boring. I already tried it last time I did live. It was crazy. But anyway, I'm gonna try to run this on LeetCode. I might have a bug in here. Yeah, it has. See, I knew I messed the syntax up. I can't remember what is hat. What is So if set is has. So what is? Anybody know what the for a map in JavaScript what it is? It has. It's not has. Shoot, what the heck is it? I don't know. I'm gonna have to look it up because I can't remember. JavaScript map. That sucks. I thought I would remember that. Oh, it's size. Or no, it's not size. It's something, ain't it? Oh, it does say has. So what did I mess up on? Oh, cannot read properties of undefined. We got new map, memo has. How is this undefined? What am I doing wrong here? Oh, I messed up here. I didn't pass in memo here. So yeah, that's why you're supposed to read through your code. That's the part I skipped. And then I still didn't do it here either. Oh no, I don't have to do it here. I just have to. I'm tripping. It ain't even here. See how we mess up so bad, man? It's here. Yep. But that's why you debug. So sometimes in an interview they'll let you run it and then you debug that and it's perfect. Like you just debug that, you find it, you fix it. But if they don't let you run the code, you have to find that by yourself, like by running the code manually through your mind. Like that junk is terrible. But you got some interviews do make you do that. But that won't be me doing that tonight. So I'm gonna go the way of a normal interview, a reasonable interview. Yeah, so these test cases passed, which is what I wanted to get back to. Now let's try it against all the LeetCode submissions again. It may not work again because it's n squared. Quadratic time isn't that great either. It's not considered that great time. Like, let me see if I can find a time complexity chart to show y'all real quick. All right. So yeah, so usually in the interview, you like if you get to linear big O of n, you're usually pretty good in this yellow area or below. Log n, constant time, of course. That's just literally basically mean no matter what the size of your input is, your algorithm always runs the same. This basically says linear says your algorithm for a space or time complexity runs linear to the size of your input. It runs as much or produces as much space as the size of your input, which is typically accepted in interviews. And log n is usually okay in interviews too for harder problems. That's basically a combination of log n, which is like basically the algorithm runs it like as it keeps running, it actually runs less based on the size of the input, if that makes sense. Like it runs like negative of n squared, if that makes sense. You got to kind of know math to know what like logarithmic algorithms are and logarithmic math is and all that stuff. But this is actually n times log n, which is also decent. It's not as good as log n, or n, but it's not the worst. It's in orange. Now when you get to n squared, you get in red, like it's horrible. Now where I was at, the first edition of this problem I did, I was 2 to the n. I was way up here. And now the new version of my problem, I'm in here. It's n squared. So I've reversed the, instead of 2 to the nth power, which is exponential, I went quadratic with n squared, n to the second power. So I'm still not in a great spot, but I'm in a better spot than I was. So at least in the interview, if I could show that I could jump from here to here, I at least could show that I could, using memoization, I could show that I could, oh, and y'all, could y'all even see that? Oh yeah, y'all could kind of see it. I might have had it messed up. Oh yeah, y'all couldn't even see that, man. I'm tripping. My fault. My bad. But anyway, yeah, so like here, my fault, y'all. You can see it now, but yeah, like this is the yellow area is linear, like that's your size of the input is growing perfectly relative to your time complexity and space complexity is growing perfectly relative to the size of your input. Logarithmic means that it's your algorithm is operating, it's basically getting like divided in half on each iteration. So you're actually doing less and less operations as you keep going each iteration, which is really good. And then constant just basically means you just do the same number of operations in your algorithm no matter what the size of the input is, which is great, which is excellent. Because that means you could handle 1 million records and your algorithm would still perform exactly the same. N log n is just a combination of n and log n, which is a little bit worse than n. And then n squared is where I'm at now. That's where y'all got to now. And then 2 to the n powers was the first iteration of the problem I did. So I did jump down a little bit, but I'm still in a horrible space considering what it's saying there. So anyway, now I've messed my screen up, but now I can go back to how I was over here. Get this back like it was. Yeah. So anyway, let's run it on LeetCode. Since I did all that over explaining, we go ahead and run it. Somebody asked a good question. How do you dang, it got accepted? Wow. Surprised. Yeah, so it got accepted 175 out of 75. So y'all saw earlier when I did it, it timed out, right? And all I had to do, it ain't simple, but all I had to do was add memoization where I actually stored the results. So it's not, this algorithm isn't running as hard as it had to run before. It's a little bit better. It's not great, but it's a little bit better. And so if I analyze it, I'm probably gonna run out of, I ran out. So you only get like one of these a day, which sucks. But so I got accepted. They actually ran it against that big, you remember that long test case I ran earlier? It had like a bunch of different results in it. I don't know if they show that on here, but yeah, they don't show it. But yeah, it means this one ran pretty good. So against 175 test cases, it passed, which is great. So yeah, that's not bad. I'm gonna answer a couple questions. So how do you use this in jobs? Yeah, I think McAdee or Mackie D answered it pretty good. It's mainly used in interviews, like these types of problems. But I will say, knowing data structure and algorithms, knowing time complexity can come up in a job. And where it comes up is when you're writing algorithms. Let's say that it's not like these problems are trivial, like they're like trivia problems. But when you're coding in a real environment, let's say inside of here, I was doing some sort of database call, or I was doing some sort of call to some API that costs every time you call it. Like say you're making a call to OpenAI to do a AI question and get an answer back. That costs money. So if this algorithm, it's a big difference if this algorithm is running exponentially or if it's running just quadratically. That costs your company money. Like if you, and I know I'm simplifying it, but this stuff comes up in real jobs, like where people write bad algorithms. Bad algorithms can take down databases because they run too many operations on them. They can take down servers because they use up too much runtime memory, or they use up too much CPU because of the time complexity. Or they could cost the company money because they're ineffectively calling resources wastefully, where you could just be like storing the results using memoization, or you could be doing some sort of optimization to your algorithm to get it to a better time or space complexity so that it saves on your resources on your server and also saves on expensive resources that the algorithm interacts with. So it is getting used in the concepts of it get used in a real job, and that's why they ask these questions. But no, like the guy, like Maka D said, you're not answering these kind of problems every day in a job. These trivial types of problems, like these are just trivia questions, really. They're a way in an interview setting to test your knowledge of data structures and algorithms. Do I agree with this way of testing that? I don't agree with it. I think you should do something more practical. And a lot of companies are starting to wise up to that and change their interview practices. But at least for right now, as far as I know, is, you know, people I know that literally just interviewed, they're still getting asked these questions by big tech and medium-sized tech and even smaller tech companies. So yeah, anyway, that's my answer to that. Somebody said you write bad algorithms by using the light theme. Yeah, man, my bad. I forgot to switch it. Like that was one of the optimizations I made last time, is switching the theme. So do y'all like that a little bit better? I'm guessing. But yeah. So anyway, yeah, that's the algorithm there. Dark theme probably look a little better. Some of y'all might like the light theme more. Yeah, let me know. I don't know. But anyway, yeah. And yeah, it depends on your domain. Like C White said, like some domains, like if you're just creating front end web apps, you might not have to do any data structures and algorithms. Or it may not matter. Like you could write a bad algorithm on the front end sometimes, and it don't matter. The browser's able to handle it. It don't matter. Like you're not handling enough data for it to matter. But as we move into the world of AI and big data and, you know, stuff like that, like it does start to matter a little bit more. And it just depends on your domain. Just like so not every job, but I have seen in my jobs and over the years, I've seen where it matters. I've definitely seen algorithms. Like I had to write this vehicle inventory processor, and I wrote the logic to like pull the data from these car dealerships, like millions, like Toyota and these huge companies, like all their dealership, all the cars, and we needed to update their inventory for their system. And it was fine when it was like running like 10,000 vehicles, but as soon as I need to run like 7 million vehicles, then the whole thing took like 4 or 5 hours to run, and it wasn't ready for. Now it ran, but it wasn't ready for the day. Like they needed to sell these new cars, and the inventory was still out of date. And so I had to go in and optimize the algorithm to run faster. And it was because of time complexity. Like I had to improve the time complexity of the algorithm that I wrote, or somebody else wrote. I can't remember. But it matters. Yeah, I mean, it definitely matters. That cost the company money, and they made more money, or they stopped losing money once they were able to actually process the inventory faster. So, and what's memoization? Memoization is basically what I did here in this problem. It's where you store the results. So like when you're doing problems that are finding the different pathways, or you're using like recursion to find the different paths and different options. Like here, what I'm doing in this if statement, like for every jump, I'm running a new jump function, and I'm finding all the different ways you can jump and the different amounts of jump you can make. By storing the result, I actually don't have to repeat that again, because what's happening is these different combinations and paths I'm going down are overlapping in what they're trying to find, and I'm just recomputing it every time when I don't have to. As long as I store the result somewhere and just keep passing this pass by reference memoization object down, I always have reference to the answers that I've already found. So don't keep trying to recompute the answers you already found. Store those answers in a object and then pull those answers when you have them. And that's what I'm doing right here. And that saves your algorithm from running too much. Hope that makes sense. Yeah, that's dynamic programming. So I was doing dynamic programming before I even knew it. I didn't even know this was dynamic programming when I first started doing these problems. So yeah, it's dynamic programming. So once you kind of add that memoization layer in there, you're like saving the results of things you've already computed in order to save yourself from having to save on a number of operations. And basically that's trading space complexity for time complexity. I'm using a little bit more space by adding this map, this dictionary, but it's saving me a lot on time complexity, which actually made this problem actually get accepted. When the first time I did it, if anybody was here to watch that, it didn't pass. And so yeah, that's where we're at with that. So now, can we do this even better than the last? I done this problem 2 times so far. Now I got it to a point where it passes, but can we further improve on this time complexity? Because like I said in this chart, even n squared isn't that great. It's still considered horrible. So an interviewer might ask you, they might say, if you have enough time, you might have enough time. But if you have enough time, let's say you did this solution first, this memoization solution. Let's say you had enough time, they might ask you, hey, how can you further improve this? So yeah, how could I further improve this? There is a way to further improve this, and what that is because this problem is only asking return true if you can reach the last index or return false otherwise. What I actually can do, instead of trying, I don't need to like find all the different combinations of like, can I go 2? Can I go 3? You know, like try 1 or 2 here, try 1, 2 or 3 here, try 1 here, try 1 here. Like try 3 different paths here, try 2 different paths here, and like just exponentially grow this whole tree out. I actually don't have to do that because I don't care about the paths. I really just care if I can reach the last index from a reachable index. I really just care how far I can reach at any given time. So like if this is 2, I really just care how, I know that I can go either 1 or 2. I really just care how far I can go. So when I'm at 2, I know I can go to at least 1. And so when I get to 3, if I know I can go to at least 1, I know 3 is a valid option because I know from 2 I can get to 3. Because I can get to 1. And then from 3, I know I can go all the way to 4. And once I know I can go all the way to 4 from 3, then I'm done right there. Like, so it really ain't even that complicated to try all these different things because I already know I can go that far. Now, when I first did this problem, I didn't think like that. I thought like I need to check all these different paths. That was hard to think of. And I think for most people, it is hard to get to that solution. That's why it's a medium problem. And even on this one, let's say when I'm at 3, I know that my farthest I can reach is over here to here. And then if I go to 2, I know that since the farthest I can reach is over here, that I can try 2. I know 2 can get me here. That's the farthest I can reach. When I go to 1, I know I can reach over here, so I know 1 is valid, but the farthest I can reach with 1 is still 0. And then when I get to 0, I know I can reach this far, but I can't reach any farther than this. And so once I get to this part and once I go to 4, I know I couldn't reach that far. That's not far as my reach. So I know I can't ever get to 4. Once I get to a place where I'm stuck and I can't move again, then I just need to return false. And so I actually don't have to do all these different paths and all this different recursion. I really don't have to do all that in this problem to do it more optimally. And so what I'm actually going to do over here is erase this. And what I'm going to try to do is I'm just going to go through each number and I'm going to check how far I can reach. And then I'm going to just keep track of how far I can reach. And I'm going to go to the next number, see how far I can reach. And every time I'm going to check if I'm at the end. If I can reach to the end, then I'm fine. But then also on every number I jump to, I'm going to make sure that I can actually reach that far. Because if I can't reach that far, then I'm stuck. There's no point in trying to keep going. And so that's what I'm going to write in this algorithm. I'm actually going to erase this for a final time. And like I said, again, I'm going to change this to const. And like I said earlier, I'm just going to loop through. First thing I'm going to write is a loop. I'm going to use let actually 0. I'm just going to write a simple loop just to iterate through the numbers I++. So I'm going to have a simple loop. I'm going to keep track of farthest index possible. Right now it's 0 because I'm just starting out, so I don't know I can reach any farther. So like I said, the first thing I'm going to check when I get to an index is if I can even reach that index. So I'm going to say if I is greater than farthest index, so that means I can't even reach the number I'm on, I'm stuck. So I'm actually going to return false right here. That means I'm stuck. I can't actually reach the end because I can't see that far. And in here, I'm actually going to shoot, what am I going to do here? Because I kind of started with this a little early. I kind of go out of order with stuff. I kind of go in the order that I think of it. I think I need to calculate the farthest index at some point. So I'm going to just do that next. And it's not let farthest index. It's already created. And what farthest index is going to be is, yeah, so whatever I am on is whatever the current index is plus, hold on. Yeah, I'm on I. It's the number that's at the current index. So it's I plus, this is the jump that you're making. So whatever that number is, wherever I'm at plus the number gives me the next jump, and that's the farthest I can go. And that'll give me the index. And if I add that, if I add this number to the index I'm currently on, that'll give me the farthest index I can reach. But that might not be the farthest index I've ever reached. So I actually need to do math max here and make sure I'm only saving the farthest. If I already got a farthest index, a farther index than that, then I don't want to use this new one, if that makes sense. I just want to take whichever max of both of these. So you could do like an if statement here and say if this is longer than this, then use that one. If this one's longer than that one, use that one. But math max actually just helps you do that in one line in JavaScript. So I either take whichever one's longer. This, I'll put it in this so you can kind of see. If this is longer, then take this one. If this one is longer, then just keep the same one I had and just restore it back in there. And then do I need to do anything else? So I'm keeping the farthest. Oh, I want to check if, let's see, if I'm at the end, if my farthest index I just created is greater than or equal to nums dot length. Dang, how you spell length? Why can't I spell length right now? I'm just screwing. I just can't spell, man. I can't spell nothing, man. It's getting too late. -1. Yeah, if it's equal to, I'll put this in parentheses or whatever. So if here, if I get if it's greater than or equal to, that means I'm at the end, so I could just return true. I think somebody just said that in the comments. So greater than, if it's greater than or equal to, so I'm gonna return true there. And then here, if I get to this point, I don't even think I can get to this point. And you might be right, a Q, that I might not have to check that if I think I still need to check to make sure I'm at the end and return true. I think just here, this probably is useless, because I think I'll either hit false or I'll either hit one of these trues eventually. I don't think I ever get here, so I don't really care what I put here. I'm just going to return false because JavaScript just needs something to be returned. But I don't think, probably never reached this line, I don't think. But this is just a JavaScript thing, just because it's just best practice. If you're returning something, you need to have all cases return something. So I'm just gonna leave that there. But I think you'll always get out here. So yeah, in this case, I'm actually going to, this be like the last thing I do tonight. This is the case where I'm actually going to run this by hand. I'm gonna check line by line to make sure it's doing what I expected. Farthest link equals 0. I'm doing a regular loop here. I equals 0. It has to be less than the length of the array, I plus plus. If I is greater than farthest index, that means I can't reach that. That means I'm stuck. I'm at an index that I can't possibly reach, that I shouldn't be able to possibly reach. So in that case, then I return false. If not, then I'm just gonna calculate my farthest index by either keeping the same index or the current index plus the current number I have that I can jump. And that'll give me a new farthest index or keep the same one. And then here, I check if my newly calculated index is greater than, if it's went past it, or if it's equal to nums.length minus 1, which is the end. That's the last index. And then I return true in that case. And then here I just return false, which I don't know if I'm even going to reach that line. So yeah, my code looks good at an eyeball test. And I'm actually going to go by this line by line, since I think this algorithm is short enough to where it kind of makes sense to do so. So I got this, I got farthest index. So how I do this to show an interviewer, if I can't run the code, I want to show an interviewer that my code works by hand. I keep track of so I got nums, I keep track of every variable. I got nums, I got farthest index, I got I, and that's all I got. I got nums length, which I can just put to the side of this. In this case, nums length minus, or I'm gonna say nums length minus 1. Nums length minus 1. In this case, nums length minus 1 equals 4, because 0, 1, 2, 3, 4. So that's the last thing. Or you can call this last index if you want to call it that. It equals 4. And then farthest index, I'm going to just go through my code and I'm going to update my variables as I go. So nums, I'm just using an example from over here. That's where I got that from. So I would show the interview using an example that it works. So this is equal to that. It's always going to be equal to that. I hit this line here. So I'm going to update my variable there to 0. I hit this line here. I'm going to update this variable to 0. Then I'm just going to go line by line. Well, I know that this ain't true. Like, I need to check this too. Like, is I less than numbers length? I know that it's 0, so it's less than numbers length, which numbers length is 5. Because it's, yeah, I just know that from just knowing that. So anyway, is I greater than furthest index? It's not greater than, it's actually equal to it, because I is equal to it. So I'm not going to return false here. I'm going to calculate the furthest index, I plus, oh yeah, I forgot about this variable. Need to actually track that one too, whatever this is at the time. And in this case, it's 2, because I'm at num 0 gives me 2. And so I plus 2, so 0 plus 2 gives me a furthest index of 2, which is greater than my current furthest index. So I would get a max of that and update this to 2. So this actually is getting updated to 2 here. Is 2 greater than or equal to nums length minus 1? No, it's not, because that's 4. So it's not greater than or equal to it. So I'm not going to return true. And I'm actually going to go to the top of my loop again. And this is going to iterate up to 1, the I. So I is going to iterate to up to 1, which will make nums I iterate to 3. And I'm going here. Is I greater than farthest index? No, because I is not greater than 2. 1 is not greater than 2. I'm going to find a new max. I'm at I is 1 plus nums is 3. So that's going to give me 4. Furthest, that's higher than the current farthest index I have. So that'll make that 4. And then is farthest index greater than or equal to nums length minus 1? It is, because it's equal to 4 is equal to 4. So I'm actually going to return true right here. Result or output actually. God dog, it's late. I'm tired. Output is 4. So I actually got, yeah, output of 4. So, or no, why did I say 4, man? Output of true, because I got right here. And that is the answer to this problem. The output is true. So it works. So I actually can try it for this one too and see if it gives me false. And that's how I would prove to an interviewer that didn't let me run the code that this works. So I could actually just replace this with that. The all this will be the same because it's the same amount of characters. This will go back to, I'm going to actually leave that empty, leave that empty, leave that empty, leave that empty, and just go through it. This will get set to 0. I will get set to 0 right here. Of course, I is not the end. I is not less than that, so I'm not going to hit that. It's equal to it. Furthest index is going to be I. Oh yeah, this would be 3 because nums I is 3. So I 0 plus 3 will give me 3 for furthest index because furthest index is 0, so it go to 3. And then is 3 equal to 4? No, it's not. So, or not, it's not greater than or equal to 4, which will be up here. So it's not. So I'm gonna go back to the top of here and increment this to 1, which will give me in a 2 slot. And then I would say is I greater than furthest index? No, it's not. So I would skip this. Furthest, then I would calculate the new furthest index. I, which is 1 plus 2, would give me 3. So that would still just be equal to 3. So the first index is still 3, so it wouldn't actually change. It would just keep the same one or just keep the same number. And 3 still not going to get me out of this because 3 is not equal to 4. So I'm going to come up here and increment this again to 2. That'll give me a 1 here. And then I'm going to skip all this because I already know all this is true. I'm going to come down here and recalculate this. 2 plus 1 still gives me 3. So I'm still not going to get out of here. I'm still going to have 3. This is going to get incremented to 3, which will give me a 0. And yeah, so this 2 and 0. Yeah, so then is I greater than, still not greater than, it's equal to, is I plus nums, that still gives me 3, so that's not changing. This 3 is still not greater than 4, so I'm still stuck here. So I'm actually going to come in the loop again to make this 4, which would give me the number 4 here. But the problem is once I is equal to 4, is I greater than further index? I is 4 and further index is 3. It's greater than, so I actually got to a place I can't reach. I'm stuck now, and I will return false. So I will actually break out of my loop here and get false, and I'll be done because I just broke out of the whole thing here. And that is what they want you to get for this one. So it looks like at least I've proven to the interviewer that for both test cases, my algorithm works. And the crazy part, if they don't let you run the code, you can have mistakes in your algorithm. And if you can prove to them your algorithm works, you could actually have mistakes in it and it wouldn't really even matter. Because it's not about the code work, it's about you understanding it and understanding that your code works. And they don't really care about you running it in that case. So it's kind of a trade-off. You kind of like don't actually have to have working code, but it's got to be like logically working, you know, in the case of like when you run through it like this. And so, yeah, so that looks like it's working to me. Next, to talk about the big O notation real quick. And I'm almost done, y'all. Time complexity. In this case, based on the size of my input, let's name that n. Again, that's num's length is n. Based on the size of my input, we have constant operations here. Like, this is going to run no matter what the size of the input is. All this in here, like these things are going to run no matter what size the input is. But what happens is they get multiplied by this loop here. However long num's length, like wherever num's length shows up inside my algorithm, that is going to scale. I'm going to do as many loops as I have number of length of the n. So that actually means that my number of operations is scaling with the size of my input. Linearly. So I'm actually gotten this algorithm down to big O of n linear time complexity, which is great. Which you look back at this thing, it's in that yellow area. So it's a lot better. I've skipped over the orange area and went down. I went from n squared in my last solution down to quadratic down to linear, which is in the yellow, which is typically good for, even though it's yellow, it's typically good for coding, for most coding interview problems once you get to that point. So anyway, I've gotten down to that. And then space complexity, I'm not creating any type of, like, all these operations, they're not creating any data structures that are growing with the size of n, num's length with the size of n, which I've declared what that is here. There's no new data. I'm not making any maps. I'm not doing any recursion. I'm just doing, no matter how large n grows, I'm not creating any new data structures that are going to take up runtime memory. I'm just setting like simple variables which are considered constant space, and they'll be garbage collected or whatever the case is, you know. And so in this case, my space complexity is actually constant. It doesn't matter what the size of my input is. My space complexity is going to stay the same. Yep. And yeah, somebody explained it, eagle fit. It's big O of n because he's running the algorithm n times. Like, basically, if I define n as nums of length, this is the heaviest part of my algorithm. Big O is talking about the worst case. This is going to run no matter how many numbers I have. This is going to run the same amount of times. It's always going to run, if this is 1,000,000, if this is 1. So I can just ignore this. This is the line, or these lines here are the ones that are going to run exponentially. And you have to, for big O notation, you have to take the worst part of your algorithm, and that's what you take as a big O. And so basically, however many of these I have, it's running linear to this. This is how many operations I'm running. It's linear to the size of my input, which is n in this case, which is num's length. So that explains that, hopefully. Yeah, and yeah, my bad, Matthew. Yeah, garbage. I don't think it's garbage collection, but at least as far as I know, it's not attributing to space complexity, just creating these variables. Because these are gonna this is not gonna be tracked beyond the scope of this, this is gonna be set up one time. Even these that are going up in here, like the I, all this stuff is just gonna get set up one time. It doesn't, like, it's not getting set up n times. Like, I is just set up one time. The value's changing n times, but it's just getting set up one time. Furthest index is getting set up one time. All my variables are just getting set up one time. But it's just how many times this runs in here. So yeah, it's not technically like garbage collection or whatever. Sorry about that. But anyway, yeah. So not that line 12. I don't understand why we're adding I to the value. Okay, line 12. Yeah, that's a good question. So I is the current. Think of, I'm doing a loop. Think of I as where I'm at in here. I is just the iteration of where I'm at. I'm just doing a simple loop through this array. I is where I'm at. When I get to, let's say I got here to I equals 1. I got to this spot. When I say I need to jump the furthest, I need to jump 3 to get to this index, I need to add 3 to I. So if I is 1, to get to index 4, I need to add this number 3 to it. And so that's basically what this is doing right here. I'm currently on this index. I need to see the furthest index I can reach by adding whatever the current number is at that index to the current index to see how far I can reach from that spot. I'm taking the longest jump possible by just adding that number to it. If that makes sense. I hope that makes sense. I know it's hard, yeah, to think about. And yes, this is a medium level problem. And yeah, thanks for that question, Justin from the 6. I appreciate you asking that because that's an important part of it. Yeah. Is this a medium question? Yeah. Is this Python? No, it's JavaScript. And I think that's all the question. Yeah, I answered the question about the I plus the N plus nums I PHP. Yeah, I mean, yeah, JavaScript. I'm going to use JavaScript. I have no shame using JavaScript. JavaScript's a great language to use. A lot of people use JavaScript. I don't know, like, don't let nobody fool you. Like, everybody's not using Python. Like, the web is built with JavaScript. You're not running Python in a browser. Like, Facebook, anything you use, any website, like LeetCode is using JavaScript. I mean, anything you run in a browser that's a web application is using JavaScript. React, Vue, all these JavaScript frameworks, like JavaScript is very popular. I mean, it's Python's rising up, but JavaScript, I think JavaScript and TypeScript is a superset language of JavaScript. They're still the most popular languages. So I don't know what stat that is saying nobody used JavaScript. Like that's crazy. It's actually like the most used language. If you count TypeScript. Anyway, what I'm gonna do next? Yeah, I'm gonna run this. Then I'm gonna run it because I already traced through it manually, so I'm pretty sure it works. So this time, since I traced through it, so that's why you kind of want to trace through it manually. So you saw that if y'all were here the last couple times I ran it, I didn't trace through it manually. I just ran it and I found bugs and I had to fix them. This time I traced through it by hand and it ran a first time because I was really sure that it was working because I was able to, find any bugs or just, verify manually that it works. So that's an important thing that why some companies decide to do it. I don't really like it, but like making you run it manually without like actual executor to execute the code or interpreter to run the code. But anyway, so yeah, I got these two test cases, which I test these two test cases too. So they better work because I did test them myself. And then you can run it against all the LeetCode submissions. And I'm hoping that it passes because yeah. So yep, passed all the LeetCode submissions. Obviously, I can't analyze the complexity again because I ran out of I don't have LeetCode Premium, so they don't let you keep running it. But I'm really sure this is such a simple algorithm. I'm like all it has is one loop in it, and so I'm pretty sure this is linear time complexity. And I didn't create any maps or any recursion. Nothing's going on, so it's pretty sure that this is constant space complexity. Yeah, so I hope this makes sense. Like I went through, this is probably one of the longer ones I did. I went through 3 iterations of this this problem, and I actually was crazy. I actually used most of the time doing a problem. A lot of times I answer a lot of questions after, but yeah, I used a lot of time doing 3 iterations. And what I wanted to show with that is when you're in an interview, sometimes they'll give you one problem, but they'll give you a multi-step problem. So they'll give you the problem starting out, and they'll either ask you to optimize your solution, or they'll throw some extra thing into it, some sort of hitch into it that makes you optimize it or whatever. And so like being able to kind of take one problem and come up with different solutions is a good thing to start to practice and know that you might have to do. Because in this case, when I first did this problem, the first time I ever did it, I came up with in my head, I came up with the solution to try all the different paths, the non-performance solution. And then I came up with the memoization solution. I was like, well, I think I can save some time if I just save the results. But I never came up with this the solution right here. I didn't come up with this on my own. Like, that's when, this is after I was like, well, I got it right, so I'm done. And then I went and looked up the answer, and I was like, oh, there's even better answer than the one I came up with. And the answer I came up with might have helped me pass the interview. I don't know. You know, it might have been enough. But like, this was a way better answer. So, you know, even when you do these problems and you think you got to the end, LeetCode tells you everything's right, gives you a great score, blah, 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 there still might be a better answer out there. And so this problem actually has like 3 different answers to it, which I wanted to kind of show that one time on live. Java is the best. Do you need to be using consts like the function headers in the interview? I would say you don't need to, but I would say it's good practice to, because with JavaScript, you have the var, you have the let, you have the const. That's the 3 like assignment. I can't remember what you call them, like assigners that you have. And if you use var, it gets your variable, your function gets hoisted to the global scope, which can cause problems. You know, it can cause like unexpected things with your algorithms, where your variable or function is in a scope that you didn't expect because it's getting hoisted up to the top of the execution scope. But when you use let, it stays within that execution scope, which is fine. And then when you use const, then that just means you're not going to be able to redeclare this variable again or get it confused with another variable because it's declared as a constant. But yeah, usually you either want to use let or const, like, because those are more var is like, it's not really descriptive of what you're trying to do, but const is basically saying like, hey, I want this to be global scope. I want this to never be used again. This is a constant. It's not going to change. It can't be changed. It's going to cause an error if you change it or if you try to redeclare it. Let is basically saying keep it in whatever scope that we're currently in. So like, that's why I use let inside of here. And so just do not hoist this outside of this scope. It's only being used in this scope, and it will change. And so if this didn't change inside this scope, I would call it a const too. Var is just too loose. Like it's like a loose, it's like it just hoists everything, and it can be changed, and it can be a const. It can be, you know, it's like it can do too many things. And so a lot of times it's best practice not to use var at all in JavaScript if you know JavaScript. So yeah, and somebody explained it. Creator gave a good explanation. This lesson made me quit JavaScript. The loops I couldn't understand, but then again, I was young. Yeah, just try it again, man. Like it's once you get it, man, it's like a light bulb that clicks, and once you get it, like you're gonna better knock it out the park, man. It's really like, I think if you can kind of understand just like logical concepts, you can understand basic programming for sure, and which I know you can. So just try it again. I know it's tough though to get over that first learning hump, or learn how to code. Like that kind of mountain you kind of got to climb to kind of get like a breakthrough. And once you get that breakthrough, then it's like off to the races. Once you kind of get that basic understanding. You're a different breed for LeetCode than JavaScript. I guess so, man. I get a lot of comments about that, but I don't know. I mean, at work we use a lot of JavaScript. So when I interview people, everybody I've interviewed for like the past 5 years, you use JavaScript. So I think it's maybe a disconnect between like real work life world and like internet world, where like everybody's using Python. But in like real life world, companies are using a lot of JavaScript because that's what the web runs on. That's what web browsers read is JavaScript. They're using a lot of Java in enterprise settings. They're using a lot of C# in enterprise settings. They're using Python. They're using a lot of Python, especially for AI and machine learning stuff. Application. They're using, some places are still using C++. Some places are using Ruby. You know, some places are using other language like Flutter applications. Flutter framework applications use a programming language called Dart. And if you write Android applications, you're using Java or what is called Kotlin. if you create iOS applications, you're using either Swift these days or Objective-C in the past. So I mean, what I would say is when you do these interviews, you want to use the language most comfortable to you. And for some people, that's the language that they're actually using. Like if I'm an iOS developer and they're asking me coding challenge, I probably would use Swift if that's the language I'm strongest with. But some people decide to switch and use a different language for their coding interviews. For me, what I want to see when I do coding interviews for people is I want to see how well you code in the language that you're going to be using every day. That's just my opinion. Like if you come to the interviews in Python, then I don't really know how strong command of the JavaScript language you have. You might be great at JavaScript, but you're not showing that to me in the interview. You're showing me how good you are with Python. And so, I think when you look up job descriptions on LinkedIn or wherever you find your jobs at, and you see what language they're using, and they're saying they're going to do a coding challenge, sometimes they give you a choice. Most of the time they do give you a choice, but I don't know. I just feel like it's better to use the language of the job that you're going for, in my opinion. But no, I'll say this. It's always better to use the language that you're strongest with. But if you can do well with the language that is of the job, then also don't forget to do that. Like, and for me, it's kind of both. Like, the language that I use mostly in my job is also the language I'm actually best with coding algorithms with. So I don't know, just use whatever you're comfortable with. You need to pass the interview, so just use whatever you're most comfortable with, I guess is my final answer. But you're gonna do that anyway, so there's only a few languages to use: Python, Java, C++, C, C++, Go, or JavaScript. I add a couple more too that you got to think about mobile development too. So Swift, Kotlin, because there's a lot of mobile developers out there. I mean, you can use cross-platform frameworks, but a lot of companies, like Airbnb is famous for dropping their cross-platform framework and going back to native mobile development using like Kotlin and Swift. So yeah, and C#, man, John Galloway, C#, that was my first love, man. Like when I first got my professional programming job, we were a Microsoft shop. So we used a lot of C#, ASP.NET, and man, C# is a great statically typed, less verbose than Java programming language. It is strongly tied into the Microsoft ecosystem, which some people don't like, but it's gotten better over the years as far as like being more open sourced and stuff like that with like ASP.NET Core. But yeah, I love C#, man. It's very good language to learn programming fundamentals and object-oriented programming. Java's good too, but Java is so verbose, man. Like if people on here complaining about JavaScript over Python or JavaScript versus Python, then Java, man, they would hate Java because it's so verbose. You have to write so much boilerplate. And but it's a great language as well. Like I know that one too. I had to use that one a lot at work. Yeah, C# is for Unity, Windows. Yeah. So yeah, Unity, man. That's what I want to jump into, game development with Unity and using so I can start using C# a lot more again. What are you using your 9 to 5? JavaScript, like 90% of the time right now. Over the course of my career, like starting my career, the first 5 years, it was 90%. It's probably like, I feel like you always gonna, if you have a job that's like full stack and you got to deal with the web, you're always gonna use JavaScript to some degree. So I think when I first started out, it was mostly C# on the back end, maybe like 70%, and then 30% JavaScript. And then once the JavaScript frameworks came out, like I'm old, I'm like been in like 12, 15 years doing this. Once the JavaScript framework start rolling up steam, then more of the logic start moving to the front end. And so I started doing more JavaScript. And then eventually, the last 5 years, I moved to a team that is mostly a front end team. And so we use a lot of JavaScript Even on the back end, we use Node, which is a framework for writing JavaScript on the back end side and building web services and stuff with JavaScript. So we still using JavaScript even on the back end. And so I haven't got a chance to use as much C# as I wanted to in the recent years. But for my personal projects, I use whatever I want. Like I still use some C# in my I was using Xamarin, which is a cross-platform mobile development framework. It's been killed off now, but it had a lot of C#. It was all C#, which was great. But anyway, is Python the best? I mean, I think some would say Python's the best. I think some would say that. I don't use a lot of Python, but it's a great language. It's great for beginners. Great for people that are doing AI stuff. It's probably the future. Python's great, man. Python's amazing. Matthew was talking about Xamarin. Yeah, Xamarin, man. I'm so sad Xamarin's gone, but they replaced it with something, but I don't know, man. It ain't like Xamarin. Xamarin was straight. Somebody said, you got a girl? Yeah, I'm married, actually. So, yeah. I got a girl, got a wife. Python's the most popular. There's no best language, only most popular. I don't know, man. I'll probably say it's a toss-up between JavaScript and Python. I think like GitHub did like the most popular languages on GitHub, and I think TypeScript and JavaScript are still the top, but Python will probably cross JavaScript and TypeScript eventually. So I think you're right, and to some degree, but I think still today JavaScript might be the best. And where's all this? Everybody talking about JavaScript is garbage. I don't. This internet, that's internet talk, man. Nobody in regular, everyday working jobs is talking about JavaScript is just garbage. Now they may like TypeScript over JavaScript, but TypeScript is just a super. If you like TypeScript, you basically like JavaScript. It's just a superset. It's a superset statically typed version of JavaScript. Everything you can write in JavaScript, you can still write in TypeScript, but TypeScript just added typing to it so that you can stop having typing errors in your JavaScript code. So it's still basically JavaScript. So I don't know. Yeah, TypeScript's greater than JavaScript. I knew somebody was gonna say that for sure. Yeah. It's like, I don't get it. Like, everything is on web now. You gotta use JavaScript. Like, I mean, I don't see. Yeah, I can maybe see people saying JavaScript is garbage and I like TypeScript better or whatever. But like, I can't see people saying JavaScript isn't popular. I can see you saying like, I think Michael or somebody on here said Python is more popular, is like rising faster than JavaScript for sure. I can see that. But like, to say that JavaScript is trash and no one's using it, that's not realistic. Like, everybody, like, go look up jobs online. Like, everybody using it. Like it's extremely used. It's the most used. Go Google. Let me see. GitHub top languages or something like that. I already looked this up last year sometime. Alright, so JavaScript, this is GitHub's report. Now, what this basically means is this is what GitHub is saying is being the most used for this year. So I think, wait, no, this is just 2022. Where is the latest one? I want to see 2024. Oh, dang, maybe Python did overtake it, man. Where is the little chart, man? I'm not trying to read all this stuff. It's supposed to be a chart somewhere. Oh, I guess so, man. I'm sorry, Michael. Yeah, this year beats out JavaScript as the most popular language. My bad, man. My fault. You right, dude. Dang. Become the most used language on GitHub, overtaking JavaScript after a 10-year run. So JavaScript had it for 10 years and it just lost it due to AI. Wow. Okay, here's the chart right here. Yep, it just passed it. So my bad. I thought I was gonna pass it this year, but it passed it last year. So my bad. I missed it by a year, but you see JavaScript #1 for the past 10 years. So it's not garbage, and it's not dead, and it's not no one's using it. That's definitely not the case. Everybody on GitHub's using it. They're either using Python, JavaScript, or TypeScript, or one of these other ones. And so even Java's #4, and C# #5, which is great. PHP dropped down a lot, man. I mean, it went all the way down. That's crazy. I don't think any of these dropped as much as PHP. Which that kind of, I like PHP too, actually. I know people hate it. And then C#, or Objective-C. Yeah, Swift ain't even on here. So yeah, I guess not enough people are using it for mobile app development. I guess there's not enough people to consider putting it on here. But it was number 10 at one place, but Swift ain't even on here. Yeah, so yeah, man. So dang, that's interesting. I did not know that it had overtook it. I should have known that. That's interesting. So yeah, I guess that, who said that? Creator. I think Creator said. Either Creator or Michael said that. So whichever one y'all said that is right. Python is #1. So hey, gotta give it to it, man. It's #1. But that don't mean JavaScript no slouch, man. It's still #2. It just went down one. It just went down one slot. So, you want to see this? Somebody want to see the chart again? I lost it now. Where is it? Oh, just close all these tabs. Yeah, here's the chart again. Anybody want to see that? So yeah, man. JavaScript is dropped down a notch, but it's still up there. And TypeScript is coming up. So who knows? I mean, TypeScript might come up. I don't know. It might not beat Java. It might not beat Python though. But also, I kind of see like, yeah, with AI coming, like Python is just going crazy, man. I mean, it started off strong yeah. So anyway, yeah, Python is just so English, like people can easily, it's really easy to learn. It's such a good entry level language. It's easy to write. It's not verbose. Like it doesn't have a bunch of boilerplate. It's just, it's really good. PHP supremacy, man. I'm cool with PHP. That was one of the early languages I learned, like before C# even. And I liked it, man. I was using it back like when Facebook was really using it pretty strong as a server-side scripting language, and I still use it sometime today, like some of my older personal projects. So I like PHP. I feel like if you use it right, then you don't run into, you can avoid all the issues and stuff. Somebody said, have you worked for Fang? No, I have not worked for Fang. I work for like a medium-sized tech company. I did interview for Fang before and passed their interviews. Like I actually passed the Microsoft interview. And Microsoft's not Fang, but it's basically Fang. It's not in the actual Fang acronym or whatever, but it's basically Fang. But I also passed the interview for Amazon, which is actually part of Fang. But I just decided not to go to those companies for various reasons. And I'm happy with the decision because they ended up having a bunch of layoffs after, like especially Amazon. Like I decided not to. I was like going to Amazon, got my interview, passed the interview, everything was good, and yeah, they had a bunch of layoffs like right after that, like a hiring freeze and then a bunch of layoffs. So I'm so glad I did not go to Amazon, but I did want to go to Amazon. I did pass the interview. It had coding challenges, all this stuff on it. Coding challenge. System design interview. It was 5 interviews, I think. 2 coding challenges, 1 system design interview, 1 behavioral interview, and then I think 1 like maybe it was 3 coding interviews. I don't know. It was a lot of interviews though. No, it was an early interview. The first interview was like a weed out interview where they kind of just like give you a coding challenge and just try to weed you out. And then the second one was like a real coding challenge interview. And then it was a system design interview where you gotta like basically they give you a system. And you got to talk about like how to scale that system and how to prevent issues and how, so like, yeah, man, it was a real interview. It was a tough one, but I was so proud of myself for passing that interview. I didn't even care that I really didn't go to the job, because I was able to sort of leverage it at my current job and sort of use it to my advantage. So it all worked out. So I'm happy. And yeah, I always can go in the future if I want to go to one of those companies. But a lot of those companies, man, they starting to do this return to office stuff. The FANG companies. So I'm not like Facebook's return to office, Amazon return to office. Like, I'm going to work from home. So I kind of been falling off of trying to get into FANG and stuff. And I feel like I already got into FANG. I feel like I already passed the interview. So like the check box to like, could I get into FANG? I've already checked that box off. So it's like, that's really when I passed the interview, I realized I was holding over my head, like, could I get into a FANG company? And once I kind of checked that off my list, I was like, I could get into one. Like, I know how to do coding challenges. I know how to do software design or system design. I passed the interview. They said I had like one of the higher rankings. And so I was like, shoot, man, that's really what I needed, man, just to know that I could. And if I'm happy with the job that I have now, then I'm going to choose that happiness over just trying to work for FANG. But yeah, if I want to, I can just decide to go later. But I'm not trying to move to some hub city somewhere. And I mean, I'm in Atlanta, so if they got some Atlanta jobs, I'd be cool with that. But a lot of the companies I was talking to, they want you to move to California or New York or Chicago or somewhere, and so I'm straight on that. I want to stay where I'm at, in Atlanta. So anyway, I was talking long about that. Will an entry level SWE role teach you how to be a SWE? Do you need to be really good already? In this market, you kind of got to be good already. You almost got to be as good as a mid-level engineer, because the market's kind of rough right now. I'm hoping it'll turn around, but the market's kind of tough. They're not gonna just hire you and try to teach you. You do need to be pretty good already. I would suggest for this market, making sure you do a lot of side projects, making sure that you even do some freelancing, man. Like, do some freelancing project. Get them to write you write a contract and do some contracting work, some freelancing work, and put it on your resume as like actual experience. Like, that'll help you. One, it'll help you learn, and two, you'll be able to put it on your resume as real experience, and you'll actually have real experience if you actually get try to find a real business, a restaurant, your parents' business or your friend's business, or somebody. Build them a website or build them a web app or build them some AI tool or code something for them and put it on your resume. Have a real link to it, like it's a real thing. Have a real contract. Say, I worked for them for 6 months to build this. That's kind of like the best way to try to get experience and really get into a more marketable situation in this market. Now, 5-10 years ago, even at my company, we used to hire people like that were straight out of college, didn't have no experience, like they just knew coding challenges, they passed the interview, and they were straight, and we taught them everything they needed to know. But now we're kind of expecting, like, and most of the market are expecting like mid-level engineers to even begin with. Like, they're not hiring many super junior engineers. But you may be able to just keep searching, you may be able to find a company, but that's not what I'm hearing in the industry. So appreciate the question, man. Let's see. He works for some. Oh, y'all talking to each other. My brother who makes a lot doing coding is teaching himself Rust. Yeah, I'm surprised Rust ain't on here, but yeah, I guess it's just these other languages are just kind of just more prevalent. But Rust, it's not that nobody's using it. It's just not in the top 10, which doesn't mean a thing. Like this, I know companies that are hiring for Rust. I was almost I got hired by this, or I passed the interview for this company that was gonna have me doing Rust, and I didn't take it because I didn't want to do Rust personally, because I had spent so much of my career doing JavaScript, C#, Java, PHP. Like, I had been doing a lot of these top 10, and I was like, I just didn't want to go into that. But I don't know. I would like to learn Rust too. So I don't know. Did you go to college? Yes. So I actually went to college like a really long time ago now, but I got a computer science degree, like a 4-year computer science degree. So back then, at least, that was the best way to enter the industry. It made it so much easier to get job interviews if you had a degree. So I'm so glad I actually went to college back then. Now today, more and more people are coming into the industry. They may have a different degree, not a computer science degree. They may have a non-technical degree, and they just learn the code on the side. Some people are joining the industry without even going to school. They're just doing boot camps and stuff like that. And so, there's different routes in now, but I still say that getting a 4-year computer science degree is still a very good way to go, because it does help you to learn how to code. And it kind of forces you to learn how to code in a sense, and like helps you stay motivated because you got that degree curriculum on your back. But boot camps and all that other stuff are great too. But it do look good on a resume when you got a computer science degree. That ain't changed in 10 years. So it is what it is. But you still can do it. You still can do it without it for sure. Let's see. I'm gonna answer a couple more questions. He said they're laying people off. Yeah, they're laying people off crazy. Like, just go look up the fangs. Like, they all laying people. Even Apple's laying people. When Apple start laying people off, it's bad. And so, like, literally, I was gonna get into Amazon, and they just started laying people off. The same week, and I was like, nah, I can't. I'm last in, first out, man. Like, I'm not about to leave a good job and then go to what was supposed to be a better job. But then if they lay me off, then what's the point? And you don't want to lead out of fear, but it's like, I don't know, man. And then they start doing Amazon started doing all the return to office stuff. And so I would have had to actually stop working remote and start returning to office with being possibly laid off. And then they were talking about you're going to have to wait a little while until we have to wait till this hiring freeze is over. Then they hit me back up again and was like, hey, you can still come now. And then by that time I was like, I don't know, man. Y'all got this return to office thing now and all that. Y'all, you have to move. And I'm like, I can't move. I got a house and everything in Atlanta, so I'm not trying to move right now. So anyway, my brother-in-law works for Amazon. Yeah, Amazon's a great company. I'm not trying to rag on Amazon. It's just my personal situation. It wasn't good for me. And I'm glad that I made the decisions that I made. And I'm also happy I passed the interview because I kind of got the best of both worlds to some degree. I was able to kind of, leverage the offer and stuff like that for what I needed. And so, yeah. It's why can't I just vibe code? You definitely can just vibe code. The AI is starting to take over. I did hear that Facebook is starting to change their interviews to be like vibe coding interviews, where they just give you a problem, they leave the room, you use AI, you vibe code. Now they're gonna give you a hard problem. That's the thing. Like, it's not necessarily easier. Like, I think people making a mistake. They think that, okay, you're not gonna be doing these kind of these coding challenge interviews like I just did. You're not gonna be doing these type of interviews, so it's gonna be easier. That's not the case. Like, I did interviews too. Amazon, yeah, one of Amazon's questions in their interview process was like build a web component. And it's not necessarily easier. It's just different. It's like you gotta still know how to build software. And it can be considered hard. They're gonna get, like, especially if they're letting you use AI, they're gonna give you a very difficult challenge to solve. And so I wouldn't necessarily just think it's easier, but I think that is a better way to interview, is to interview like vibe coders, because that's what they're asking you to do on the job, is to use AI. So why not interview you that way? So I agree, that's a good change to the interview. And hopefully if Facebook is doing it, then other companies will start to doing it. And then I'll probably stop doing these coding challenges live. Most likely. How much time would you give yourself to prepare for FANG interviews? Months, at least months. Now, if you've already been working in the industry, I'd say you probably could get a FANG position like everybody's day ain't the same. If you're working a full-time job, then it may take you 6 months to a year to land a FANG position. If you don't have if you're only spending like 1 hour or 2 hours every 2 days or something like that, Now, if you don't have a job and you're literally spending every day doing coding challenges, you probably can get a FANG job, and you have learned how to code already. You probably could get a FANG job in a few months, like 3, 4, 5 months, 6 months. It just, their process is so long. It usually takes 3 months just to get hired anyway, because their process is just crazy. But yeah, I think for Amazon, it was like a 2-month process just to get all the interviews done. Because of scheduling and just all kind of issues. But to learn and be prepared to do the interview, it just depends on where you're at. But I would at least say probably at least 3 months. I mean, to really, it just depends, man. I think if you studying every day 8 hours, you might be able to do it in 1 month. It just depends on how you're using that time. So it really is the hours you're putting into it, and not just the days and time. It just depends on the quality of time, of how you're spending the time. Do you think it's possible to land a job just using plain JavaScript without libraries like React? Yeah, for sure. Yeah. So last time I was doing interviews for front end, I was doing front end interviews. They would you can use a framework, you cannot use a framework, because there's so many frameworks that are out there. They're not gonna, unless the job is very specific in the job description, like you're gonna have to interview in this interview using or the recruiters telling you like you have to use this framework. Most of the interviews I saw, they either forced you to use pure JavaScript, or they said you can use any framework that you're most familiar with. So a lot of times they'll just let you use the one you're most familiar with. So I will say, in any case, based on your question, you should definitely make sure you know pure JavaScript at all times. You should know it very well. Even if you don't use it, if you're using TypeScript or using frameworks more often, you need to know it. You need to know the basics of what you're doing. You just have to, in my opinion. PHP mad good for SQL databases. You mean like MySQL, like running queries through MySQL and like accessing databases. Yeah, I see what you mean. I like building scripting like databases, putting stuff in database and pulling it out with like PHP scripts. That's what I still do that to this day. So I agree with you there. What's a dictionary? A dictionary or a map is like it's a key value pair data structure where you have a key. The key has to be some sort of like integer or string, has to be some primitive value. Or no, I think a key can be an object too in some languages. But either way, you have a key that gives you access to some data. And the most important thing about a dictionary is that it allows you to access those key value pairs in constant time complexity. So by accessing that, the keys are indexed in the dictionary, and by accessing that value at that key, the programming language typically can do that very fast without having to search the whole dictionary. So now if you put something in an array, you store something in an array, it's harder for it. And you can store it by index, because an array itself kind of has a dictionary system to it too by its indexing. But let's say you wanted to search something out of it, it can be a very expensive operation to do that. But for the dictionary, you can set different keys for key value pairs in order to access that data really fast, which helps optimize algorithms in these types of problems that I just did today. But yeah, I'm gonna answer a couple more questions and then get off of here. It's been a little while for sure. I think I might have got all the way to the top of the questions I already answered. Yeah, shell. Yeah, they're talking. Yeah, when they're talking about shell, they're talking about in this. I think somebody was asking what do they mean by shell, and I think they just mean terminal commands, shell commands. It's a lot of programming that goes along with just writing just shell commands. I don't really do it. I don't know much about it. I don't do it, but I just know a lot of DevOps folks that do it, and people that are programming closer to the machine languages, like operating systems and stuff like that, are doing a lot more of that. So, yeah, I'll put it back on this so people know what the heck I was doing earlier. Why are you using a lambda here instead of a regular function? Or why aren't you using a lambda here? I think we're just asking. LeetCode just didn't do it, but I mean, I can change it to do that. I mean, I could just update it like that. And then if I run it, it'll probably just give me the same thing. Yeah, so I didn't do that. LeetCode, I think because LeetCode was just, these problems were created years ago. I think LeetCode just hasn't updated to using like lambda functions. But that's probably the only reason. But yeah. C will always be the fast. Yeah, C is a really fast language. Alright, let me see if I answered some at the bottom that I missed. I talked for so long, I probably missed a lot of questions. Yeah, man, so many questions in here. Yeah, I talked about Meta using AI during the interviews. Yep. So hopefully that changed the whole industry. But it doesn't make the the interviews easier just because you can use AI. I think they're gonna adjust for that. They're gonna make the interviews really difficult. Like, it's gonna be either like a lot you have to do in a short amount of time, even with AI, or or something like that. But it won't be necessarily easier. Will AI destroy coding careers? I don't think so. Like, I made a whole post on my accounts, like all my social media accounts. I'm streaming across everything right now. You can go find it. I just made a post about that. Like, AI isn't going to destroy coding careers. Now, are there going to be less jobs, less programmers? I do think that's true. Is it going to change the way we work? For sure. But, AI produces compounded errors, right? So, like, AI is going to get smarter and it's going to produce less errors. And I think that's going to help. But, like, AI right now, once it start, like, if it's unchecked and unmonitored, the worse that it performs. Like, when there's no human intervention and it creates an error, it accepts that error and then it keeps creating errors on top of it, which is called a compounded error problem. That's what I see happen a lot with AI that's unchecked. And so the further it goes, the worse the technical debt gets, and it gets to the point where it can't dig itself out of its own hole that it dug. And so you need a human in place that knows what they're doing, a programmer, a software engineer that can fix those things. So I think software engineering is going to turn more to less about coding so much and more about like using AI as a tool to build software. So we're still going to be software engineers and we never really worked just coders. The job title was always software developer and software engineer for like 10 years now. And so it always was about using the best tools and not necessarily always coding. Like, the job wasn't just only coding anyway. A lot of the time was spent more reading code than actually writing code for most developers. So I think it's just going to change the way we work. And that's just one of the reasons why. And then you need humans in place to sort of bridge the gap between AI and the real world. And there's just some things that AI just doesn't have a reason to make a decision to make unless you tell it. Like, there's certain things it just doesn't have a reason to think about unless you prompt it to do so. And you need those people in place to be able to kind of be the supervisors behind it. And like, yeah, you can say that they're going to fire the whole dev teams, but like, a CEO is not going to just be sitting there writing prompts all day. Unless you're like at a startup. But the CEO of like, some big major tech company, he's not going to just fire all the devs and just going to be sitting there writing prompts by himself. There's still going to be devs that are going to be doing context engineering, prompt engineering, software development, heavily relying on AI. So I think that's the future. That was a great position to go for to get into the door. Do you mean like to get into the door of like being a programmer, software engineer? There's a lot of different routes there. I mean, a lot of people will try to come in through like the IT route or not IT, but like the help desk, which can be hard. It can be a difficult job. It's tough to deal with customer issues day in, day out. But I met some I know some like really talented people that started there, and I could tell, I'm like, yeah, you about to change over pretty quickly here. And so that's a great way to kind of get into a technical role, to go for a tech company, find a support role, And that's a great way to sort of build your skills up on the side of that to try to pivot into like another technical role, like a programmer, IT, DevOps, cybersecurity. But that's a way to get in the door without just trying to grind and just go for your first job being a cybersecurity role or a programmer role or whatever the case. So there's just multiple routes to get into there. That's one way. But yeah. How long do you take to prepare for interviews? Today, because I got a lot of experience, I probably would start doing interviews probably after like a month of preparation. Like if I didn't have a job and I was just preparing all day, every day, I'd probably take a month and then I would start doing interviews. I would probably start doing some interviews that I kind of like don't really want the job. Or not don't want the job, but like I'll probably be doing like my low-hanging fruit interviews just to get kind of practiced. And if something good comes out of it, I'll take the job. If not, if I fail those interviews or whatever, I kind of won't care. Because you kind of got to build your confidence up again to be like, of being comfortable in interviews. That pressure, they're kind of testing pressure, man, which I don't like. They're kind of testing your ability to handle unrealistic pressure. Like you don't even have that kind of pressure in a job. Like even when you have deadlines and stuff like that, you still don't have that kind of pressure. Nobody's telling you, I need you to complete this assignment. And sometimes, but most of the time you're not getting asked to complete this assignment while I sit here and watch you for 30 minutes. I need you to do this assignment perfectly in 30 minutes while I'm watching you. Like that's not realistic. So anyway, what are your tasks day to day? I work mostly with JavaScript, doing web development. I'm a principal engineer, a principal software engineer, so I'm more or less doing a lot of more like architecture, so like system design, so like I sort of create solutions. Like I work with stakeholders and find how to build technical solutions, create solution documents, diagrams, stuff like that in order to present to technical teams and non-technical teams, be that bridge that sort of like at a higher level solve some of the larger company problems with technical solutions. And then sort of work with the developers to like have them start to implement it. Some of it I implement myself, but a lot of it's like more or less delegating to other developers and working with them to be able to take ownership of that and being able to communicate this stuff to others, to leaders and other stakeholders in and outside the company. So, I'm fortunate enough to get promoted to a principal engineer now, which is like one step above a senior engineer. So I've been in it for a little while. So my day-to-day kind of varies from like meetings to doing technical solutioning and reading a lot of code, reading technical articles and like doing solution design, studying different technologies. Like it just varies. How many leak codes do you think you'd be comfortable with until an interview? So it ain't really about the number of leak code problems. I would go and study the basics of it, and what I always recommend, I do this every time I get on here, is a thing called Algo Monster. This is how I spell Algo Monster. What Algo Monster helps you do is they help you find and this ain't the best place. I think it's, why does it keep doing that? I think I have to, yeah, but I'll show this chart here. So Algo Monster helps you, it's showing how much I've done in each of these sections, but Algo Monster helps you learn the patterns, the data structures and the patterns and the algorithms the fundamentals that you need to know. Instead of doing 1,000 leak code problems, it helps you, like backtracking is what I just did today in this problem, and a combination of backtracking and like depth first search. And I did dynamic programming. It's a combination of that too, which is down here, dynamic programming. And so, but this teaches you the different patterns, and it teaches you on level of ROI. So it teaches you the ones that come up the most in interviews based off of real interview results that have happened. And so, Algo Monster, once you learn these, it forces you to kind of learn these different patterns, and you'll learn how to assign these problems with this flow chart here. Is it a graph? Is it a tree? And it'll kind of tell you you look at the problem and you'll be able to start to detect the patterns of like, when do I use one solution with this problem? And you'll start to be able to do pattern recognition, and it'll make it easier to solve multiple problems because now you know the patterns and which solutions lend themselves to which types of questions. And that makes it easier to do more lead code problems versus just trying to do 100 lead code problems and just memorize all the solutions. You actually know the patterns and how to solve any lead code problem that comes your way because it's going to lend itself to one of those problems. And so, got my first job at Meta starting at September. Kind of scared. That's amazing, man. Like, or I don't know, his name is Gigi, so I don't know if that's a man or woman, but that's amazing. Like, I'm glad you did. I know you're probably moving because I think Meta makes you move, but you're gonna probably have a nice, cool office and like fancy, tech office, and you're gonna like have great thing on your resume. So congratulations about joining Meta for sure. And yeah, you're gonna get some great experience there too, like big tech experience. So you're gonna be able to get any job after that. Just bring Fortran back. Yeah, man. I haven't used Fortran, but I know a lot of people talk about that. I have fond memories of it. Should I focus on JavaScript or C++ for making video games? For making video games, I actually would say it depends. If you're trying to make video games in the web browser, then JavaScript for sure. If you're trying to make video games for like other platforms, I actually would recommend using Unity or C# is actually a good entry point to video game programming. So we're learning C# as the language and Unity is the framework. So look up Unity, and it uses C# as its language, and it actually allows you to develop for different gaming platforms using C#. I think that's a good entry point for getting into video game development. If you're building games for the web, then JavaScript and probably some sort of like graphics framework within JavaScript. And I think Unity produces web application games too. As far as like actually trying to get into making video games, I'm not a video game developer, so I don't know the best way, but I think you're on the right track with C++ if you want to get into like the traditional like Xbox, PlayStation, computer games. Somebody else in the comments, y'all let me know what y'all think. I think C++ will probably be a good way to go. But I actually would focus on C# and to get your feet wet, learning C# and then learning Unity. That's where I would start if it was me. All right. So like UML diagrams, yeah. So like I write UML diagrams. Sometimes it's not UML. Sometimes it's just system design diagrams, like how different systems interact. Sometimes it's documenting how systems currently work. Sometimes documenting how I want systems to work. Sometimes it's creating whole new systems, how those systems scale, how they cache information, just like we did in this problem today, to save on system resources, how different systems talk to each other, how they stay secure, how they interface with each other. Like all that kind of stuff is stuff I typically think about on a daily basis. How to solve problems sort of at the company scale, sometimes at the team scale, but a lot of the problems I'm trying to solve is like at the total company scale, based on the position that I'm in. And that's what I would hope. I mean, I don't want to be doing just, team level work forever, especially after like 10 years in the game. I've never used Unity or C#. Yeah, so I mean, man, Unity is highly regarded. Like it's a great framework and for building games, and a great entry level point into game development, because it is different than application development and other types of development. So yeah, and then C# is just a beautiful language. Period. Like it's statically typed. The syntax is nice. May not be as nice as Python, but it's pretty nice for object-oriented programming language that's statically typed. So it's pretty good. Whittington's on here, man. You joined late. I'm about to get off of here, man. I don't know if you've been on here. You just joined. What's up, man? C# a little too ghetto for my... C# is ghetto? Hey, that's crazy, man. C#, I feel like it's a more clean version. I would call Java ghetto, because Java got a lot of... a lot of old trash in it still, like a lot of old like verbose, just boilerplate, just trash that you just don't need. And at least C#, when Microsoft made C#, they at least took that out. And he said, not as ghetto as your as your PHP. Yeah, PHP, man. If you want to call that ghetto, I could call that ghetto. But some of the stuff I do with PHP to this day, man, it's like it's a scripting language too. I'll just write a script, throw it up on a server, and I'm just ready to go on. You know, it's pretty ghetto. I will say PHP is it's the ghetto of the when I'm looking at these and I might want to pick the most ghetto one, I'm gonna go with PHP for sure. Because Python's like top of the line now. JavaScript and TypeScript, I wouldn't call them ghetto. I'm gonna call JavaScript a little bit ghetto. C#, I'm actually not gonna call it ghetto because I like that. C++, not gonna call it that. C is really fast, so I'm not gonna call it that. PHP, man, but I still like it though, so I ain't even gonna hate on it too bad. But yeah, so what else? PHP still got more legacy nonsense than any other language. Yeah, PHP it's got a tough history, man. It's got a tough history. It's rough, but I still use it. I use it really safely. C++ and C are definitely ghetto. You'll see this quickly in a large code base. Yeah, I don't even want to see. I don't even want to, and no pun intended. I don't even want to see that for real, man. Like I don't want to see a large. I don't think I've seen a large code base with C++ or C, because all the companies I work with never used it. They either use Java or C# or JavaScript or something else. So my main experience with C++ and C was in college with these small applications. I don't even want to see that, man. Like C++ with the header and implementation files and all that crap, man, in a large code base, that would just be terrible, man. All those freaking files, and the verbosity and just like garbage collection stuff, and I don't know, man. I couldn't deal with it. That's why we have higher level languages to not have to deal with all that stuff. Yeah, man. Yeah, y'all follow Whittington, man. He's a trip. His content. And I mean, he got good, like, smart content too, but funny content as well. I think that's probably about getting to the end of the questions. I usually program in English now. Oh, you talking about just AI? Just like vibe coding? I'm guessing. I mean, it's all English. I mean, that's what the programming languages are. It's just programming languages themselves, especially these high-level languages. All they are is abstractions of like machine code. So like the machine don't really care. Like these are things that people have made to make it where we can maintain code and software easier. But all programming languages are just abstractions written in like English to help us maintain code and share code between each other and stuff like that, and help us better develop software and share, maintain code and review code and stuff. But as AI comes in, you actually kind of come to a point where the AI really care about all these abstractions we've created? We've created abstractions on top of abstractions. Like you think about JavaScript is an abstraction of what a browser really needs. Like a browser don't need to read human language to issue commands. That's just what we need to write it. And now that you have JavaScript, then you build JavaScript frameworks on top of it, like React and Vue. Then you build frameworks like Next.js, and so you're just building frameworks and abstractions on top of abstractions. And so when you have an AI write that stuff, do you let the AI write in Next.js, or do you just let the AI write in pure JavaScript? Or do you decide to let the AI, like in the future, let the AI write in some sort of browser language that we can't even humans can't even read? Like, does it really even matter once the AI gets good enough? Does it even matter to have these human dev experience, abstracted languages and technologies. Like it might start not to matter as much, because every time somebody make a new framework or language, they're just basically giving their opinion on how they think we should develop software and what is easier to help us develop software that's less buggy and more performant and all that stuff. But once you have AI writing, you actually wanted the AI to deliver more deterministic results, and you kind of wanted to choose the same. For some things, you wanted to make the same choice every time. You don't want it to get confused between languages and this and that, and like how I should name this and what I should name this and what's the best practice for that. You kind of don't want the AI to have to deal with none of that human stuff, because it don't really care as much. It really cares about issuing the commands to the machine and whatever you tell it to write in. So I know I'm going on a rant, but I'm starting to see where, there's been over the years, there's been a lot of fight about which JavaScript framework's the best and which tool is the best in this language and framework is the best in this language and which CSS library is the best. And it's starting, like, when you have AI, are we really going to need to fight over that stuff anymore? Like, just the AI is going to write it now, so you don't have to complain about, it's hard to write in this and it's hard to write in that, and the team's not going to understand this. When AI is writing 90% of the code, does it really matter about like your team and who likes what and who? It don't really matter no more. The AI is going to write the code. So, I think we're going to start to see where a lot of these abstractions start to mean a lot less and less. And ultimately it's just writing ones and zeros, which is control switches. So I actually do predict, and this might be a stupid prediction, but I do predict that some new like lower level language is going to come out just strictly made for AI. Like, it's a language that AI can use, like for browsers, a language that AI can use for like OS, like, apps that are like desktop apps, mobile apps. Like, it's going to be a language that is geared toward AI writing it. Very unopinionated, not as human readable, probably not human readable at all. Like, why does it need to be? Like, it just needs to be enough to where AI can understand it perfectly and make less mistakes. Because one of the reasons AI is making a lot of mistakes is because of all the different contexts it needs and all these different technologies we're using and how we hook these technologies together, and it just gets confused because it's just so much out there. But once you simplify the language and the tools that it's working with, and you take out all the human aspect, because like humans care about variable names, but the AI really just needs a key to the variable. It don't care. Because you think about like JavaScript, when you minimize a JavaScript file, it's not human readable as much anymore. You're naming variables like A, you're naming variable Y. That's really all the AI needs. AI, just like the browser doesn't need a human readable minimized JavaScript file. It just needs to make sense. And so I see AI kind of going that direction too. Just like you minimize a JavaScript file for a browser to be able to load it quicker, there may be some language, that low level language that arises that's geared toward AI that people that they start using, so that AI makes less mistakes. So I'm just venting, but yeah, I might make a video about that, because I think it's something that's coming that not a lot of people are talking about, that's my opinion. It may not come that way, but that's what I see. So anyway, what's the largest code script you ever written? I don't even know, man. Like one file, you mean? Like, shoot, probably, thousands of lines probably, and which is not great. Because a single file, you probably want to start breaking it down at that point when you got that many lines in a file. So I don't know. I guess code scripts, I probably haven't written that long a code script, because I think when they start to get a single line or a single script starts to get too long, I start to break it out into different, start to separation of concerns, and I'm probably like starting to break like the object-oriented principles, depending on what language I'm using. I'm starting to just break principles of like reusing, code reuse. And so I probably would start breaking it down. So I don't know. After like start to get to like 1,000 lines, then it probably starts to get a little crazy. But I've seen files with thousands of lines in them for sure. But yeah, I don't know how much. I mean, I know I've written hundreds of thousands of lines of code myself, but yeah. So team has to be able to debug it. So yeah, I could see that, but I think you're talking about the AI thing when the AI starts. If this situation, I'm saying, if AI starts to have its like own programming language that like humans really don't have to read, what I'm predicting is that the AI will get so good that humans won't really need to review the code anymore. You know, like, because right now humans got to review the code because there's so much context and problems and so much abstractions we built that benefit us. Programming languages like JavaScript, Python, they benefit us. They're not really benefiting the computer as much as they're benefiting us. They're readable languages to help us write code. The AI and computers don't really need that. They need like the ones and zeros. They need machine code more or less, because all of it's being a programming language is being compiled down to just machine commands eventually. So why is the AI just why not a day when the AI is just writing machine commands at some point? Like, it doesn't need all that stuff in the middle. If it gets good enough, if like it's making less percent errors than humans make, then there'll be no reason for humans to write code anymore. I hope that day don't come, but that's what I'm if the AI got that good, I'm hoping the AI never gets that good, but if it got that good where it makes less mistakes than humans, then it would be no point in a human being in the process at all. So I'm hoping that's not the case. I made a video about it the other day. I don't think that'll be the case, but I think it'll be the case where there is some language is produced that is a lot more geared toward AI, is what I'll say. Maybe it's still human readable too, so humans can kind of get in there and figure out what's going on. But it's not gonna be like Python. It's gonna be something that gears more toward how AI works, a language that's more geared toward that. And so it's not gonna be made for humans. It's gonna be made for AI to read. And the AI reads English too, but it's a little bit different. If you want to optimize what the AI is reading, it's a little bit different than what humans are reading, if that makes sense. So it doesn't need all those words and verbosity and stuff that we need as humans to make sense of stuff. It don't need something to say if this then that. It might just need letters to say I, T, T, whatever. It may not need a whole word to say if this then that or whatever, or while loop. It don't need the whole word. It just maybe needs to know that W means wild, like just simple, like minified code, or just simple keys and things to simplify it. So I'm just kind of ranting now, but anyway, where can I get a challenge for beginner JavaScript? I will go to let me see, JavaScript, I think JavaScript 25 or something like that, or JavaScript 100. I can't remember what the heck it's called. It was something. I mean, maybe go to Free Code Camp. That'd probably be good for you. Yeah, Free Code Camp. It's free. So, I mean, that's a good place to go. Learn JavaScript. Build up skills. But, I mean, you got so many options now. You got YouTube. You just got to find the best way you learn. There's all kind of stuff like that. AI testers will be a new job market. Yeah, I think anything AI for sure, man. I agree with you there. It's time to embrace AI. Like, you just have to. Like, and yeah, somebody said AI is already rewriting itself. Yeah, I mean, it's already to the point where, we're rewriting, where AI is like able to kind of rewrite itself to some degree. I think right now you still need humans in place because of the compounding error problem, where it just kind of keeps it doesn't know it made an error, and then it just keeps building upon it, and without a human there. And then there's still things the AI like needs to be hooked into, integrations that need to be made. If you ever heard of MCP servers need to be created. So there's still a lot of work to do for humans, for AI to be able to interact with the real world like it needs to, and be connected into the current systems we have today. But yeah, eventually, it's gonna probably become less and less need for us, where we're just more or less supervising AI versus doing what the AI is doing. And that's why I do see that a programming language will probably arise that'll be in between the AI and the machine code, for like, or the AI in the browser or whatever. That's gonna be more better, more, it's gonna be optimized toward AI reading and writing versus human reading and writing, because programming languages we have today are geared toward human reading and writing, and then they get converted to something the machine can better understand. And so I think we're going to have something that's a little bit closer to the machine AI side, that the AI is going to be to understand a little bit better. And you're just going to tell the AI what to do, and it's just going to write you already can ask AI to write you machine code right now, so to some degree, or a lower level program, you can ask it to write you C code or assembly language code, something that's way closer to the machine. So yeah. Anyway, I think I'm gonna end it right there, man. It's been 3 hours. It's been great. I appreciate everybody that's joined the live, especially on TikTok. I think that's where I get the most people, but a lot of people were joined on I think everybody left, but everybody that was on YouTube, TikTok, appreciate that. IGBO, Eagle Fit, appreciate that, man. Appreciate you joining and commenting. Everybody that joined and commented. Instagram, appreciate y'all. Twitter, I had a lot of people on Twitter. Appreciate y'all. On X or whatever. Twitch, had a couple people on there. Appreciate y'all. If you want to follow me, DM me if you have questions that I couldn't answer. I'm open to DMs, of course. Follow me. Follow each other. Connect with each other. I see a lot of conversation, especially on TikTok. And yeah, man, it's just keep building upon this thing. I'm going to keep doing problems like this, at least for the foreseeable future, till the companies start to change it. And then we'll start doing different type of interview problems on here. But I'll keep on trying to teach on here, and it also helps me learn here as well, myself. So I appreciate y'all, like people that jumped in and helped me out and gave me comments and fixed some bugs for me and all that stuff, man. I appreciate y'all. So yeah, I hope y'all have a good night. Appreciate you hanging with me till like it's 2 something Eastern here. So appreciate the people that hung with me late. And yeah, catch me in the next one. Catch my content. I post content multiple times a week, programming content, tech content. So just connect with me, send me messages or whatever. Like, I love to connect with y'all. And yeah, I appreciate it. I'll see y'all in the next